Let's see. All right, people. Hopefully you can hear me. Um, Mark is here. I'm gonna bring him in a second. Um, just so you guys know, I want you to know we have a guest tonight. You might have seen him on NASA's Unexplained Files, One on Earth, Aliens on the Moon, the documentary that was done. Uh, what was it, back in 2014? Um, and a guy that's quickly becoming one of my favorite people in astronomy. Ladies and gentlemen, joining me, Mr. Mark D'Antonio. Mark, are you there? I'm alive and well. Now, let's hope the chat can hear you, because I'm not sure if they're going to be able to or not. I just want to see what I just want to make sure this is working. Let's see. So, chat, you're going to have to let me know if you can hear Mark. As I said, Skype's being a little funky tonight. Okay. Yeah, we have to give them because I think we're on a 30-second delay. So chat, yes, definitely let me know if you can hear Mark. I know you can probably hear me, but let me know if you can hear Mark. Okay, so that's gonna be fun. Let's see here. Yeah. Okay. Yeah, I knew they probably. That's possible. Let me see here. Oh, you know what? Let me try something real quick. People in the chat, hold on 2 minutes for me. Let me try something real quick. Okay. Default, no, no. That's not gonna be it. It kind of makes you appreciate what Bill does. Hi, everybody in the chat. I'm actually putting the mic up just to confirm that nobody can hear Mark still, and we're working on it right now. Oh, who ever thought it? Astronomers can be defeated by Skype, but yeah. Yeah, we'll definitely get it. And I do have a message in to Bill. So hopefully for guys who can't hear Mark, but we'll be back streaming here soon. As soon as we get it on, we'll be ready to go. And as I said, we are streaming till 11 o'clock tonight. So, I mean, we have plenty of time to figure this out. Hopefully, Mark at least has a little bit of time to put up with uh, our noobish, our noobish setup we got going on here. So we'll be right back. I'm on it.
Yeah.
And yep, and you're on it too. Okay.
Cool.
All right, so I'm gonna mute that. And then I am going to just use the mic audio. So we're just going to sit here and talk, and I don't have to put my mic through the actual streamer. Okay. So let me go up here to this. All right. I'm on it. All right. Let's try this again. Ladies and gentlemen.
From the beginning, as if you didn't. This is as if you haven't done it before.
Yep. Let me make sure I got all this here. All right. Everybody, let me know in the chat if you can hear Marc D'Antonio. Hopefully you can.
I'm here too.
I'm hearing him. His voice is coming across on the little blip. So I will wait for the confirmation from chat, and then we'll get this party started. Oh, man, what a night. That was what, 50 minutes, 45 minutes?
Yeah. Was it that long?
Yeah, it was just about.
This is how we do it.
Yeah, we are here. Thank you once again to Bill, New York Skywatcher, who actually just helped us out big time getting this fixed. So once again, I'm hearing everybody is confirming that you are on, Mark. So once again, Marc D'Antonio is with us, one of my favorite astronomer guys, quickly becoming my favorite, I should say. And so, Mark, how are you doing? Let's try this again.
I'm doing great. I'm doing just great, man. I'm having a good time. I'm noticing that we got some beautiful views of the moon tonight. It looks fantastic.
Yeah, it's looking really good. And we actually did a sun stream earlier, which I think we called a satellite crossing the face of the sun. So,
you might that's like a half a degree or so of space. That's a fairly large piece of sky that you could catch something, especially when there's so many tens of thousands in orbit.
Yeah, exactly. And I'm going to isolate it tomorrow, and I'll have it up on the channel for anybody that wants to see it. We'll slow it down and zoom in on it and stuff. So, Mark, we got a ton of questions from the chat here. And we'll start out with the one that stuck out to me earlier that somebody had asked. And somebody had asked, why do all the craters look like they're the same depth? And I'll let you take it away and explain it in as much detail as you can.
Okay, well, what's funny is the craters, of course, are not all the same depth, but because the moon is so far away and because we only see it from our vantage point of 240,000 miles or so on average, then they all look like they're the same depth. Now, this also goes to speaking about how craters are formed. And there's a number of ways craters are formed on the moon. Many of them are what are called simple craters, and that's the actual name for them, simple craters. And simple craters are basically like little bowl-shaped depressions. So figure an object coming in, at maybe 12 to 15 kilometers per second, hits the moon from an oblique angle or directly above, but it's small enough so that it doesn't actually release that much energy. It doesn't do too much damage other than, of course, obliterate itself. All impacts are catastrophic, don't get me wrong, but there's minimally catastrophic and there's maximally catastrophic. Maximally catastrophic is something like the Oriental Basin on the moon, which is just a huge, very complex impact location where a massive object hit the moon at some point in its past history, probably during the era of bombardment, which was 3.8 or more billion years ago, right? So we're talking, very, very, very early in its history. And the smallest craters, and things that look like these little tiny bowls, those are the craters that people pick apart from some Apollo imagery and say, look, that's a radar dish or a dish on the moon by an alien species that put a dish on the moon. Well, every crater looks like it can be a radar dish when it's a simple crater. Right. The next level up, now those are little bowl shapes, and there's plenty of them. Okay, like if you look at Copernicus and you just go, east of, let's see, north is up. If we just go westward of Copernicus, you can actually see, not in the stream right now, but you can actually see little tiny depressions when you zoom in. And if you really want to see the moon in ultra detail, but not live, you can go to the LROC, LROC, Lunar Reconnaissance Orbiter Camera website, and look at what they call the quick map. And it's all one word. So LROC quick map. It allows you to zoom in down to literally where the details are only, like 2 meters. You can get 2 meter boulders. on the moon, and zoom into some features that big. Now, that will show you the many, many more craters that we see that are much shallower than the biggest ones that we can see from the Earth. So there are various depths. They're all various depths, and the simple craters form those bowls. The complex craters, that's another one. The complex crater, that one has some really interesting features too. Complex craters generally will penetrate deep into the moon. They have a high impact, and when they hit the moon, they are obliterated. Like with the complex craters, like I said, every impact's catastrophic, just to degree. So when they hit, they eject lots of material. That's why you see rays from Copernicus and Tycho and so forth. But then when the moon surface is pulverized, it's also made molten at that point, and the rock, through the energy released, is simply melted. And so you end up getting the material acting as if it's a liquid for a period of time. So sometimes it could be 6 minutes, it could be 2 hours, that the whole impact process can take, depending on the size of the impactor.
And the amount of heat and just the amount of energy coming in from a meteor can be immense. I mean, you're talking about instant liquefaction.
Yes.
That's what you get, those center peaks inside of craters and whatnot.
Well, in the complex craters, yeah, and that's right. And when a large energy impactor, I'll call meteors impactors because they're impact generating things. When the impactor hits the moon and it has such high energy, that energy gets released primarily, as you just said, via heat, but also that liquefaction you're talking about. When that stuff goes down into the moon, it makes a gigantic, well, for lack of a better term, splash.
Right.
But that splash goes up through this transient crater, it's called, that first crater that's made. And then that stuff comes back down into the center, hits it all from all sides, hits the center from all sides, and forms a central peak. Now, that central peak, the mechanism by which central peaks are made are multiple. So there's a lot of ways that central peaks are made, but also understand that including with the central peak, with even larger craters, you can get rings. Okay, those are called peaking rings. Peaking, peaking rings. And you can get those rings the funny thing about these peaking rings is that for most of the craters where they exist about halfway out in the diameter. So it has to do with the distribution of the material that's falling back in, okay? But those peaking rings are made on the way out. When an impactor hits the moon, boom, that stuff starts spreading out. You get this mountainous heap of stuff all spreading out from the center really quickly. And when it's large enough, you get an even larger impact occurring, a larger effect occurring outside where the peaking ring is being made. But that large sloughed off stuff from the center is being pushed out where it freezes in that ring. So that makes like these mountainous secondary rings within craters. You also get terracing like you see in many craters. Copernicus, in fact, shows a lot of terracing in the walls. And when you go to the LROC Quick Map browser, zoom in to Copernicus and just marvel at this amazing imagery of these terraced crater walls. And you can see this is physics in action here. You're actually watching physics in action. Now, the reason that some of these craters look like they're flat bottomed is because they are. Now, why is that? The reason that you see that is because on some areas of the moon, you notice there's a lot of mountainous regions, and there's also a lot of areas that look relatively flat. Well, they're anything but flat. Okay, obviously when we went there, and the LROC browser can show you directly, even in the most placid-looking part of a mare, Mare, the sea on the moon, you can actually see that there's thousands of craters, per square mile in such an area. So it's not flat, but those are areas where a lot of magma, when the moon was hit by so many impactors, the impactors caused a lot of molten material to be generated. And this molten materials overspread the moon, didn't go up to the highest mountains, which is why you see it approaching some of the highest areas and then stopping, all right? And then it ended up, going to all these low-lying areas. I like looking at Plato, for instance. Plato is a lava-filled crater, all right? That crater has a flat bottom. Again, go to LROC and you'll see it's not really flat. But you can see that it actually looks flat. but it's not flat. I mean, it's wavy. So there's disturbances that took place within Plato, but for the most part, it's a lava-filled crater. It was fairly good size. I think it was Plato's 60 miles across, isn't it?
It's
Isn't it about 60 miles? Test.
Yeah. Yeah. I'm thinking. Yeah, it's right in the 60-mile mark. It's just right around that anyway.
Right, and just west of Plato, you can see the edge of a larger crater that was filled in more completely. Now that crater is like 4 times the size of Plato, and it looks like the edge of a mountain range, right? Okay, and this is down below. It's east of Sharp, and south of Herschel. It's kind of in that region near near Plato. It's in that sea area, just southwest of Plato. My gosh. And that area shows an area that was overfilled by lava at one point. So, we can use like craters that are well defined and distinct that hit the maria, the surface areas of the seas, the darker gray areas on the moon. We can use those as an indicator of relative age of the impacts. So the maria are relatively clear of impacts in much of the cases, right? Because you look at the lunar highlands and they're just peppered with craters. You look at some of the maria and they're not so peppered. The reason is, of course, because they happen, the peppering of craters that happened on the maria happened at a different era, different time. The era of bombardment, which is my favorite time because I wasn't around then and nobody could have been or should have been. The era of bombardment was great because that's when the moon was peppered with everything you see. For the most part, like 99.9% of these craters that you see on the moon were made back right after it was, created, after it was born, so to speak. And that era of bombardment, which is just a really tumultuous time for both the Earth and the moon. Now, the Earth had a way of dealing with those. We had an atmosphere. It was a very dense atmosphere, primordial. We had a lot of constituents in our atmosphere that led to a lot of carbon dioxide.
Other words saying we had help.
Yeah. I mean, there's plenty of help. The Earth itself was able to use a level. There was erosion, and on the moon, where there's no atmosphere, there was no erosion. So we look at crater impacts in the highlands, and we're seeing these crater impacts as they were probably almost 4 billion years ago.
Yeah, and don't let it fool you guys that just because the Earth does have impact craters on it.
Yes, it does.
There's just a little more hidden. Yep.
Yeah, that's right. I mean, the Manicouagan Reservoir up in Canada is the northeast version of the Barringer meteorite crater in Arizona. I mean, Manicouagan Reservoir is huge. It's a massive ring from an ancient impact crater, from an ancient impact. And then we have it's called Chicxulub. The famous what used to be known as the KT boundary, the asteroid impact that killed the dinosaurs.
Yep.
That's actually they've dropped calling it the KT. The boundary is now called the Jurassic, or it's now called the KP boundary. Okay, so it's actually the boundary with the Paleogene now era. But that's not a big deal. The thing that's interesting is that our planet has been peppered, and we've had 5 major extinction events on this planet that eliminated a great deal of life with each incident. Yet, through the holes created in that record, okay, or in the life paths, okay, the holes created, there were species that could take advantage of it. And a question I had recently was, how come dinosaurs didn't just come back, once they were made extinct with that by asteroid? Why didn't the dinosaurs just come back? Well, the answer was because their genetic material was destroyed, and entire lines of evolution were wiped out. We've had more species die on this planet than probably are alive. So that's what's interesting, about a planet that has air on it in the habitable zone around its star. Mm-hmm. That doesn't mean we're safe, as you can tell from our history. You look at the moon. The moon shows what a violent history the solar system has had.
Especially the backside. I mean, I know I asked this question for the people in the chat. The reason why the backside of the moon, or the dark side of the moon, quote unquote, is more crater filled than what the front side is. And I know there's been a lot of scientists that kind of argue back and forth about why that is. What is your thoughts on that, or why the backside is more heavily cratered than the side facing us?
Well, certainly tidal locking has something to do with it, and the moon, one side of the moon always faces us, and as you said, the quote unquote dark side. Obviously, the moon gets lit on all sides. When it's a new moon, the dark side's fully lit. So and at any one time, 50% of the moon is always illuminated. It's just we can't see it all.
Right.
So the fact that the one face of the moon is always turned toward us, that tends to be more protective, and it tends to mean that only impacts that could miss us, all right, could somehow get to the moon. Now, the moon is not really that close to us. I mean, if you had an Earth and you put it, say, let's see, a little softball size. Okay, the moon's going to be many feet away. It's going to be several feet away, like a couple tens of feet away, and it'll be the size of a much smaller, things like a little bit bigger than a marble, smaller than a golf ball, that kind of thing. Mm. So the bottom line is that the side of the moon that was always facing the Earth in that tidal locked situation was more protected than the backside of the moon. The backside of the moon could take and field impacts from anywhere else coming in from out in the outer solar system or whatever. But the inside part of the moon facing the Earth would actually be more protected. And just because the Earth was there, again, it's not that close, but the Earth's gravity well, the gravity of the Earth would pull many of those meteors that might have gone to the moon off course and toward us. Maybe they impacted with us and didn't impact with the moon. So that's my thought. I think that's probably got a lot to do with it.
Right. And I'm going to start grabbing some questions from the chat here. The one question I saw a while back is, what are your thoughts on the moon ringing that happened back in, I guess it was the 60s, I think, did they crash something into, my brain's not working right now for some reason, but they said the moon rung like a bell.
Yeah, well, sure. But see, the Earth can ring too, and it did. In fact, when Krakatoa blew up, okay, they could hear the seismic responses from that explosion, reverberating through the Earth. Now, in fact, in seismology, we use that a lot. We use sound to actually penetrate the ground, and based on the nature of the echoes returned, it tells us something about what's below. And this is how, for instance, we know we have a molten core, a solid core with a molten outer core. Okay, this is how we know that the moon, is pretty much dead, has no tectonic activity at all, doesn't have any, molten core, and so it's how we know that. And now, the thing that's interesting is that we have, geologic systems on Earth that can generate a loud tone or a noise or explosion or something like that, and send shock waves. Well, right. when the moon ringing was heard, the moon ringing was extremely different from the way the Earth would ring. Now, Earth is a lot bigger, and the sound has the ability to be refracted a million different ways on the Earth, and on the moon it wasn't quite the same. So these sounds are used to tell the composition that we cannot see, that we can't get underground to see. A neat experiment, and it'd be actually kind of cool to do it nowadays, and to be able to detect the differences that we could see now. If we can be so precise with our oil hunting equipment, for instance, then we should be able to land something on the moon to do this decisively and figure out more about the moon's composition.
Not only that, but the fracking technology, the way they're going in and cracking, rocks with liquid. I mean, you figured that would be something that they would want to introduce up there, especially if they're going hunting for anything actually under the surface. But yeah, it's just amazing. What other question we got in here was the moon anomalies that I think you had talked about in the documentary. For some reason, the name is escaping me again. The one that you did.
Aliens on the Moon?
Aliens on the Moon, yeah. About the bridge that was caught and the satellite dish and, all those basic images. What's your thoughts on that?
Well, I'll tell you this, okay? I'm a science guy, so that doesn't mean I don't believe in aliens. I actually do. I mean, I make a break, and I've made breaks with many scientific people because of the fact that I'm willing to speculate on alien life, for instance. Okay, so one of the things, hang on, I was trying to. Okay, one of the things that I was thinking about is when they came to me and said, we want to do this show on the moon. You're the guy that we want to go to. You're the the image guy, blah blah blah, and they they build you up, pat you on the back, say, well, you're the best, whatever. Okay, well, I felt okay.
Which I should add in there before you continue, Mark. I should add in there. Mark is currently one of the guys that does the heavy investigation into the photos for MUFON. I don't know if I said that in the beginning. I just wanted to make sure to get that out there. He does work and does photo analysis for them. I'm sorry. I just wanted to make sure.
No, that's fine. No, I'm MUFON's chief photo and video analyst. So, I'll see. Sometimes I'll get 100 or 200 cases a month. Sometimes, but and sometimes there's some very high priority ones. But, stuff with the moon, for instance, like when you had that one sighting of the satellite crossing the moon, some couple months ago, and of course it went viral all over the world, which says, hey, you're succeeding. Okay.
To our good friend Scott Waring, that made it go all over the place. Jeez.
Right, because he's got a ready-made system of making money on other people's work, but that's okay.
Right.
And so the truth is with the moon, I've always felt that I don't think there's any proof that aliens have not. And see, this is a negative thing. Let me say it this way. We can't prove aliens don't use the moon for a technological stop-off point. Mm-hmm. Anyone that observes the Earth for a period of time, who's got half a brain, would recognize that we don't have a big presence on the moon anymore. And they would be able to set up an observation station or observatory of some kind to watch the Earth distance. And with technology they may have, they could very well watch us from there. Now, that's my thought on whether they could be here. I don't discount it out of hand, is what I'm saying. But I haven't seen proof of it either. And when they asked me to do the show, I said, well, I'll be happy to explain these things like the bridge crossing here, the dish on the moon. I'll be happy to explain what I believe is happening. And I actually went to great lengths to do that. In fact, I have. Let's talk about the bridge. There's an area on the moon where there seems to be a bridge that's extending like an arch from one section of the moon to another. It might be I forget how long it was, like 60, 70 miles or something like that. 70-mile long stone bridge or something. And they were trying to say that it was created by aliens. Well, I said, I looked at the light that was hitting the moon at the time. It was a very shallow light. And the photo was taken, I think, from Apollo 15 command module. I could be wrong. Well, anyway, that photo ended up going viral because people said that this shows an area on the moon where an alien bridge has been built. Okay, well, let's test that theory. And the way I test theories is not by just saying I think it's this and leaving it at that. I try to recreate it. I try to build one myself. So
not only that, there is precedent for a bridge to actually be made naturally. I mean, especially if you got to Utah and stuff, you'll see natural arches there. Now, obviously, the atmospherics are different between the moon and there, but there is a precedent for that. Arches can be made naturally at some point in time.
You're absolutely right. They can, and so I had to investigate that. I actually visited. Not personally, but I visited one online, and I downloaded a lot of things about the stone arches out in Utah and Moab, I think. And I looked to see not only similarities, but how they were formed. And I realized that, unfortunately, for those to be formed on the moon, there would have had to have been some kind of erosion taking place, some kind of atmospheric interaction. And that's not questioned. We know there's no atmosphere on the moon. So that had to go out the window. So I looked at another option. I figured, okay, then maybe this is an illusion. And I know that people said it was the detractors would just outright dismiss it, wave their hands and say, oh, it's just a trick of the light and shadow. Well, if it was, I didn't want to just wave my hand and say that because I'm not like the rest of people. I had to show it. I had to prove it. So I actually looked up the properties of the lunar soil. I started digging through it, and I began actually to create my own lunar soil. They would have the same static properties, the same compression properties, the same powder qualities, and the same glassy properties.
And this is what we call science for the win. It's about recreation, and confirming observation.
That's right. Exactly right. And so what I did was I recreated lunar soil, and I made this gigantic vat of it. And I said, all right, if there's supposed to be a bridge material that we can make, then or bridge rather, then I should be able to make it out of this material. So I tried to make it, and I realized it's not going to work. And I told him that. And then I then said, well, let's look at the light. The light is low-angled light. And the photos don't have a lot of dynamic range, which means that what's black may be hiding other structure. So I did something else. I made two valleys side by side. Okay, so one valley went down and up to a little ridge, and then down and up again to a flat plane. Okay, put the light down low, and when you look at that ridge that's illuminated, the valleys are dark. And I took photographs, and I showed how the valley, when it's illuminated, the bridge is totally overexposed, because the dark of the valley, to be exposed right, that ridge has to be overexposed. Okay, but when you expose for the ridge and you make the ridge perfectly right, then those dark valleys are totally black, and you've got a bridge.
There you go.
So I figured that bridge was actually truly a trick of light and shadow, and I showed it. I didn't just talk about it. I showed it, and this was it. And when I showed the producer that, he said, wow, that's great. That'll never get on the show. Exact words.
Oh boy.
All right. And so I realized that was their agenda. So for most of that show, I think I'm heard saying, well, this is really interesting, but then they cut off the rest of my sentence where I say, but this is what I think it is.
Right, and that also comes into play with the Apollo stuff, which we'll talk about in a little bit, about the tricks of light and shadow, and basically debunking the debunkers who thought that we actually never went. But on a personal note, you are an astronomer yourself. You do work with telescopes and whatnot, correct?
Yeah.
Yeah. So let me ask you.
I'm building an observatory right now, actually.
Let me ask you, what do you think of our good friend Paul's work here? Because when I first seen what he was doing from Miami, I was completely blown away at the imaging he was getting.
Yeah, I think that the moon is actually a fantastic subject for a stream, because the moon be subject to the same issues as a faint nebula might. Especially if you're in Miami, you're in a location where there's a lot of skylights, domes of light and stuff. So the moon would be impervious to that, because it's so much brighter than that per square field.
Right.
So I think that it's beautiful, and it's really good. I love when he does the extreme close-ups, and you see the turbulent atmospheric cells. The wavering and the motion of the moon. Obviously, that motion is imparted by our atmosphere. It's not imparted by the moon. The moon's not sitting there waving at us.
Well, we and Paul have been doing this for almost a year now. And when I first came across him and what he was doing, I was like, wow. I was like, I could maybe, tweak this a little bit and actually get somewhat of a little better image, because what he was putting up before was just stellar. But I was like, I wonder if I could, and then I started putting it through mine, and we started getting like more and more clarity and I want everybody to know, for this channel, if it wasn't for Paul, this channel would not exist at all.
He's quiet. You never hear from him. He's like,
yeah. Well, I actually talked to Bill about that, and I had talked to Paul. We had a Skype conversation about a week ago or so.
Yeah. And
I'm going to have Paul come on with Bill on Bill's channel one night. That way Paul doesn't have to be working and, working the scopes and everything, just relax and have a good conversation, and people can ask him questions, because a lot of the people that are on this channel also are on Bill's channel. So, but I want to put that out there, Paul. Amazing work. All these people are on this channel and following because of the work that you do. So great job.
Totally agree.
Amazing stuff. And which brings up, I definitely want to get into the Apollo thing, because you have your NASA deniers, and there are a lot of them that don't believe a thing NASA says. No matter what NASA says, they just totally chuck it off like it's like they're just feeding us a bunch of crap.
Yeah,
So,
I mean, I don't know why they do that, but I get that. You know, they do that,
it's
and it's like
government.
I call them science free. You know, they're science free. When you're science free, you can make up the rules any way you want. You know.
And it's almost feeding itself.
Yes.
You know, it's more and more people get into it that have it's fake. But you made it a point to debunk the debunkers at one point, which I found absolutely fascinating. And not only that, but you showed the evidence to back up exactly what you were saying.
Yeah.
This is what I want to talk about. So for all the things that that people have been saying about debunking the Apollo missions and whatnot, we can start off with the biggest question we get that I actually have a pre-made answer for on the text, which is basically, why can't we see the lunar lander and the flag and all that kind of stuff with a telescope from Earth? And I'll let you just go ahead and tackle everything from the Apollo missions, and because you pretty much, I'm sure you pretty much know all the questions that people always, or accusations they always make. So
yeah, take it if I miss one, you can go ahead and throw one in. You know, sure. That's fine. Sure. Well, to answer that first question about why we can't see the lunar landers and so forth, my answer says who? We certainly can. You can see the rover tracks. You can see experiments. You can see the descent stage left on the moon. Again, what I told you about right at the beginning of the stream. You know, if you go to the Lunar Reconnaissance Orbiter, camera site, LROC, LROC, and do the quick map, right, all one word, you will see different sites. In fact, those are sites that are highlighted. You can select them from the left. There's a drop down.
But to their what that is they're in orbit around the moon. And I'm talking about views actually from Earth, from an Earth-based telescope. Even the Hubble, which is only like 2.4 meters or something like that, you'd have trouble with it. So it's hard to explain resolution and size, especially in a short chat box. But basically, if I don't know, you might be better at this than I am, of shortening up, just giving an answer why we can't see it from an Earth-based telescope, even with a beautiful 10-inch telescope like Paul has. Why can't we see the sites where they landed?
I can give you an analogy for that. Okay. The reason we can't see where they landed is one of, as you said, resolution and capability of your telescope. First of all, from Earth, we're looking through an atmosphere. And when you look at the zoomed in views up there on the view that we get from Paul, okay, when he zooms in to its tightest and closest, you can see this wavering and shimmering going on all the time. That totally destroys any capability to see anything that's smaller than a certain size. And that's certain size, I'm not sure what that limiting resolution is here for the stream, but that smaller size is something that is immensely larger than the biggest object on the moon that we left behind. So there's no way to even see that just because of the atmosphere, number one. But let's say we're in space and we're in orbit and we're looking out that way. If we're in orbit and using the Hubble and looking at it, we still can't see anything on the moon because of the fact that it's so small relative to the capability of the instrument. All right?
Exactly.
Another way to say that is this. Stars have a discrete diameter in the sky. They're not just points of light, okay? But they have a discrete diameter. But that discrete diameter is smaller than any instrument on Earth is capable of resolving. So if you wanted to see Alpha Centauri, the nearest star system to us, and you wanted to look at the main component of Alpha Centauri A, and you wanted to look at that star and see it as a disk, you'd have to have a telescope that was be the equivalent of taking a quarter, a 25-cent piece, moving it 760 miles away, and being able to see the face of the quarter with a telescope from there. That's the kind of problem we're facing here. So you see, even without an atmosphere, that wouldn't be possible. So this is what we're facing. And so that's why we can't see these from Earth, all right? And that said, I think that that's the reason we can't see features like that.
And I did a video on the channel page. This might be almost a year ago, where we actually we took Google Earth and we measured the size of the place that Apollo 11 was, and that whole area alone would fit between the east and west wing of the White House. Yep. Right? It's that small, and just the size. You can get up there and measure time. Once again, the images that Google Earth uses are from the LRO sites. where they actually captured everything. But I think, was it the Japanese space agency or somebody else also has moon orbiter photos as well? Might have been the Chinese.
There's actually both Japanese and Chinese have photos as well. The Chinese had them in support of their mission, which was a successful landing of their rover. And the Japanese have it as well. They're in concert, I think, with the ESA. But those missions are, they have their own reasons for doing those missions, and sometimes those missions don't include high-resolution cameras. Sometimes they have other instruments to look for some kind of science, because we know what the moon looks like. So seeing it visually is almost not that important for some science packages, So being able to detect the residual magnetic field, if there was any, be able to detect deposits of different minerals is hugely important, considering the thoughts about mining on the moon, getting some titanium and helium-3 off the moon. Okay, those kinds of things are very important to us. So mapping the moon's geology is probably the most important thing we can do. So we're underway. We have a lot of that under our belt already.
Are you one of the people that think that we should go back to the moon before we start looking towards Mars?
Well, I think we will have to. I know Elon Musk talks about being to the Mars by 2020, okay? But the problem is that we're not going to be able to go to Mars with any certitude of reaching Mars. Now, the Orion spacecraft is wonderful, but we only just had one crew do a simulated test so far where they went inside of a dome. Okay, I think they just came out actually not too long ago, and they successfully went for however many days they had to, cooped up in a habitat the size of what might be a Mars habitat. The problem with those types of studies is they know they're going to get out at the end and see blue sky again. When you go to Mars, okay, and I'm not getting off the moon question, we'll get back to it, but when you go to Mars, you are going to be there and never get back, most likely, okay? So what you see is what you got. I mean, the new series Mars, by the way, is just wonderful because it actually highlights some of these problems, where you basically, once you're there, you're there.
Right.
And, and I'm sure they, we'll figure it out. But the early visits to Mars are going to take a long time, and we're going to need to probably end up building a lot of spacecraft up in orbit because we haven't harnessed gravitons yet. We haven't harnessed gravity waves. We know they're there, but we can't physically alter them. Once we can reflect the gravity wave, we'll have anti-gravity, and we can do what we want. But we're not there yet. It's probably another years away. But now, coming back a little bit now to go back to that moon, we talked about the features that you can't see, like the lander and the descent stage, rather, and the rover tracks and stuff like that, except from a moon orbiting satellite.
Right.
The other issues that a lot of the moon naysayers were throwing at us were that the shadows in the photographs seem to be going all the wrong way. This one seems to be heading off at a 30-degree angle, then right near it is another one going at a 42-degree angle. What the heck's with that? How can that happen? Well, it could only happen if they were using studio lighting. Well, that kind of issue is one for which I built that lunar model set, and we showed that wasn't happening. Then another one was where on, I think, Buzz Aldrin's helmet, there was a splotch which somebody said was a reflection of a studio light. And I said, well, okay. I said, that's a good find, except I think I know how that happened. Because in some of the video, you actually watch how he raises and lowers his visor, and it's with the hand on that side where the splotch is. So clearly, he had some lunar dust on his hands, probably on the back side of his thumb, and when he went to pick up that visor, he kind of scraped up the visor with this material, which, by the way, was like pulverized glass. All right, the lunar soil is not soft and cuddly. It's, if you were thrown into a vat of it, you would emerge totally ripped to pieces with bleeding, because it's really sharp stuff. Several astronauts had their suits cut, and one astronaut, I think it was Schmidt, he couldn't do his last space or moonwalk because his suit was already cut on the ankles down to the insulation from just moving along on the moon. I mean, that's how abrasive the stuff is. Okay, so it had that quality. The other quality it has is that it would go and get airborne. And inside the lunar module, where there was not supposed to be any dust, there was dust clogging filters inside in the air breathing compartment. Okay, so the stuff was getting everywhere. And so I actually made for one show, I can't remember which one, I think it was, maybe it might have been season 3 of NASA's Unexplained Files. I made a helmet, and I applied some of my moon dust to it, as I made the visor go up and down kind of a thing. And I showed how that splotch was probably just where he stopped when the visor was up, and where he reached to pull the visor down, he left a residual amount of stuff on his visor. And believe it or not, I actually kept doing that. I kept raising it up and then lowering it, raising it up and lowering it. And right where I was doing that was a splotch very similar to what they saw in the photos. So I think you err on the side of reason and say, well, because the moon dust gets everywhere, and I made moon dust that gets everywhere. Trust me, you see my special effects shop. Okay, it's everywhere. To
it's
this
like
day,
a shop vac blew up.
Yeah, you know what? That's right. I mean, it's got light particles, heavy particles, whew, crazy stuff. So yes, so that's what I had to do for that one. And so, there's that thing. Oh, we use studio lights. It's the shadows are going the wrong way. Blah blah blah. And then there was the lighting on the lunar module. The back side of the lunar module was brightly lit. It seemed like it was brightly lit. But wait, wasn't that supposed to be the dark side where there was no light?
Right.
And I did my analysis, and you can tell that I'm talking as if I'm a debunker guy. I did my analysis, and I saw that the brightness of that lunar module was brighter than the moon was reflecting. So how could it possibly be the moon that was reflecting? Well, it wasn't fully the moon that was reflecting. Okay, in fact, the moon only reflected about like 11 or 12%. That's the reflectivity. So that wasn't nearly enough. So in a sense, it sounds like I'm agreeing with them, right? Well, and they were saying, well, because it was studio lights and other things, that was what was illuminating it. But it was actually the astronauts' own suits. And you only saw photographs, nice, really good Hasselblad photographs taken by the other astronauts, and you saw the lunar module. What you didn't notice is that the astronaut himself who's taking the photos has a very brightly sun illuminated suit. It's the only white thing on the moon.
Yeah.
Okay. And it was reflecting a huge amount of this light onto the backside of the lunar module.
A lot more than the actual dust itself.
Yes, as a matter of fact,
reflectivity was like what, 22% or something like that, compared to the dust that was 12.
Yeah, the suit was 88% actually.
Yeah.
Okay, the suit was reflecting 88%. Okay, especially the design material. They can't get too hot. And so it was 88% reflectivity. So those suits were lighting up whatever they were near, like Christmas trees. They didn't need flashlights in the dark because their suits, as long as they were still in the sunlight, they could see everything in the dark just fine, as long as they didn't have the gold sun visor down. So I mean, I think that's again, that's part of the problem here, is that assumptions, and not, if they don't understand the science or they don't take the time to learn it, then they're subject to their own they're subject to their own fantasy, and they sometimes can compound it by adding to it and say, well, I don't know, I think those must be aliens, and if they say that enough, they might start believing it. And I don't discount that aliens can be there. I just discount the fact that we've found them. I don't think we have. And I've gone through and I've done several shows like this, and where we've talked about alien life and moons and all that, but I just don't think that they've made themselves aware to us if they're here. Not yet. We gotta work at it.
Yeah, and I don't know. I mean, the way I look at alien encounters or UFOs is they've been going on for so long. There could be a public psyche to it, or it's just because of how many there have been.
Yeah.
It has to be looked into a little bit more seriously than what, say, the government looks into them. You had Project Blue Book back in the day, which a lot of files didn't even come out of that. They only published the not so good ones. But I mean, if it's something like, if somebody over 300 years has told you that, ketchup is yellow, and tens of thousands, hundreds of thousands of people have been saying ketchup is yellow, wouldn't you want to, look into it just to be sure, get in depth and prove that it's not yellow, it's in fact red, or
totally agree.
There's a chance it might be yellow,
You're right.
So the fact that everybody makes it a joke or humorous, or, when you see it on mainline news stories, they always wrap it up at the end, with a nice little giggle, like, oh, the little green men are coming.
That's
do
right.
I think it's possible that they're here? It's definitely possible. Do we have any definitive proof? Not yet. But if Paul keeps on going the way he is, I'm hoping we catch some.
I think that's. I'm all for that. I think that's fantastic. Now, in to add to that, okay, Dave Schock as the CubeSat. Dave and I are good friends, and I'm working with Douglas Trumbull, who of course is the Hollywood special effects legend who did Close Encounters of the Third Kind, Blade Runner.
And I will just add that we will be having Dave Schock on in the next month or so, for anybody that doesn't know him. But he's doing the CubeSat, UFO Disclosure CubeSat. We'll get into that when he comes on the show. Sorry about the interruption.
Oh, no, fine. You had to say it.
Yep.
But I'm working with Doug Trumbull and a team of scientists that we put together from Lawrence Livermore. And we're working on a project to actually find UFOs in a scientific manner. Our project's called UFOTOG 2, which Dave Schock knows all about, and Dave and I talk about collaborating all the time. And UFOTOG, UFOTOG numeral 2. The reason it's 2 is because there is a UFOTOG. And UFOTOG was Doug's original invention, where he created a Humvee and had a telescope coming out of the center of it on a pedestal with it's called a theodolite, a pan and tilt mount, basically. Mm-hmm. High capability, high quality, and he could follow and track anything that came into the view of the telescope, and it would follow it and just track it in real time, and bring down information from multiple instruments that are on that unit. Well, I saw it, and I was actually doing an NPR radio show on the X-Files, and the host of the show after it was over said, "I got to get you on with Douglas Trumbull," and I went, "Doug Trumbull, my childhood idol. The guy's like." Movie making, visual effects genius. And they said, "Oh yeah, he's a big UFO hunter too." And I was like, "What? Really?" So I went home and I wrote him an email. I found his email on his website, and I wrote him an email and told him about it. And he went to my website, saw all the visual effects work that I do for my business, and he wrote me a page and a half back, like less than 2 hours later. And I was like, "What the heck?" And he said, "I went to your website. Excellent work in every regard. Come on up. We got to talk UFOs." And he says, "I'd love to meet you, and we could use you on a project we're doing right now."
And what is your website name, just so people know?
Well, my website is fxmodels.com. That's F Foxtrot X-ray M models, Mike ODELS. So fxmodels.com. And you see some of our models up there and stuff we did. But when I talked to Doug, and you can reach him at douglastrumbull.com. Doug and I, we kind of hit it off in regard to visual effects goals, where we wanted to go with visual effects, and we think alike on that. And with UFOs, he kind of said, "I've never seen one, but I really want to see if they're really here." And I said, "Okay, well, I think you did a great thing here with UFOTOG, but that's one vehicle, and it cost you a huge amount of money." I said, "What if we just design something that's a small platter that can be just remotely left in the desert somewhere by the hundreds, that can detect something, and then maybe signal our cell phones, through some mechanism somehow?" And he's like, "Oh, I love the idea." And he's the kind of guy who, in spite of all his fame, the guy's an Academy Award winner, for crying out loud. Despite all his fame, he'll sit there and say, "Oh, great, take it and run with it. I'm happy. Let's do it." So he's a huge collaboration guy. He'll be happy to just jump in if you have a good idea. That's what I like about him so much. And then he left me alone on that, and I started putting together a team of scientists, which I did, and I put together one of the guys actually that the guy that created whose team created the Clementine Lunar Orbiter camera, all right, is on the team. He's our lead scientist, and he's working with us, and another guy who worked on that project is with us. And the Clementine probe, gave us a really good map of the moon for its time. LROC, of course, done far better, but Clementine was sort of the first mapper that actually really mapped the moon in a usable way. And after that, other orbiters followed suit and so forth. But anyway, so this guy's top in his field. He's really wonderful, and he's helping us. And we have a camera now that actually we have to just get the chips for, and then we can have our camera part of our UFO system, UFO detector system. Now, my whole goal was, if aliens are using the moon or anywhere else, we should be able to detect them, not by seeing them, because most likely, as we talked about, a small alien vessel won't be visible from the Earth in the same way for the same reasons we just talked about.
Right.
We don't have the resolution or whatever, but we might be able to detect radiation being emitted from it that shouldn't be getting emitted from, say, the moon. So if we see something, say we saw a little tiny spot cross the moon, like you saw that what we thought was a satellite crossing the moon.
Mm-hmm.
But suppose we got gamma rays from that. And suppose that at the same time that it was crossing the moon, we noticed that we were getting a stray change of the magnetic field locally, or additionally, like the electro EMF was building in the area for some reason. Then you see it goes from a black nondescript dot now to perhaps a smoking gun. Now we detected technology, advanced technology in use. So this kind of thing is where we're heading, and that's the kind of thing that I think is gonna really reveal any alien visitation on Earth, on the moon, or anywhere, is by looking for the things that we can't see, looking for radiation signatures that are left behind that are systemic to using a advanced propulsion system.
And not only that, but bring in the non-visible spectrum into the visible, through ultraviolet, infrared, that kind of stuff as well.
Our system does UV and IR. That's what we want to do. We're also going to do. We already have a gamma ray detector. We're just in the process of miniaturizing it, and then all of it's going to be powered by solar panel array per unit.
Mm-hmm.
And we're going to put them 3 at a time in equilateral triangle layout, like a mile apart, so we can triangulate and get distance for anything we see. Out to a certain distance, that'll work.
Beautiful.
So, it's going to be great. And we've been talking about this. I talk about all over the country, and I've been, with every conference I do and every talk I give, I make sure that I let people know this is happening. And I'm not asking for their money. I mean, we're looking to get it privately funded. Doug's talked to, Richard Branson. He's actually been talking with Elon Musk of late, and they're trying to get some kind of, they're trying to do something together that will lead to getting this thing done. So it's all about science, and it's all about saying that, look, if they're here, we should be able to detect them, and because we can't see the technology being used directly yet, we can see what I'm calling the skid marks of that technology.
Right.
And that's what they call it. And I know it's funny, and every 15-year-old goes, he said skid marks.
Not just 15-year-old.
Oh, sorry.
It made me laugh.
But that's what I say. I call it's the skid marks of alien technology, that we're actually looking for. We're looking for that little leftover residual that we can see in our XYZ, dimensional space. Remnant of a trans-dimensional ship, perhaps. And that's not so far-fetched anymore when you think about string theory and you think about how the universe may actually work.
Right.
So there's a lot of really interesting possibilities here. And I know that goes way far out there into the future, which is something that skywatchers looking at the moon may not necessarily be interested in. But you should be interested in it for one reason. This is where science is going. And we are going to be heading into the realm where we will have interstellar travel, perhaps in as little as 300 years.
And you can almost bet in the next 20 years, space is going to become the next frontier easily, with everything with the graphene and carbon nanotubes and everything coming up.
Yes.
There's going to be a lot of innovation, and that's probably the best part about having privatized companies getting into space exploration, because you don't have to rely on taxpayers. You don't have to rely on governments doling out budgets so much when you have it privatized. That's also going to come in here because NASA's learning a lot of stuff on the back end. stuff that really not a lot of people think about, but they know that we need, and be able to share that information with privatized companies. It's just going to make it better. So in the next 20 years, if you have kids and you're telling them what, you want to put a little bug in their ear, what to get into, definitely science and space exploration should be right there at the top of the list.
Actually, I think that you'll find that in addition to those scientists, the scientists needed in those fields, we're also going to be looking for people that are very much into planetary geology.
Yeah.
Because we're going to be able to, and not just be able to, but it'll be required of us, if we're going to leave this planet, because our sun is going to eventually exhaust its hydrogen fuel and blow it up into a red giant in part of its end day phases, where it's going to swallow the earth and vaporize this planet. This planet is finite in its lifetime. It's going to end, and we have to get off of it. Now, that's not going to be for several billion years, so don't start packing yet. But we are going to have to get off of it. And to get off of it, we have to start thinking about getting to the next frontier, getting those minerals that we need off the moon, stop pillaging and raping our own planet when we don't need to do that anymore. There's so many energy possibilities for us now that we just don't look at because we seized upon dead things. And now we're burning dead things for our fuel, right? I mean, that's a famous quote that, I think Michio Kaku had said, we still burn dead things. And we do. But, I look at the ceaseless cycles in the ocean. I invented these Gulf Stream windmills. I came up with a plan and a design for Gulf Stream windmills that would slowly twist in the Gulf Stream and generate power, massive amounts of power. And if a whale went into these fabric veins, it would swim right through and not even get stuck. If a submarine accidentally went through there, the wrapper would just sort of slough off it and go. The wing, so to speak, would just slough off. It's not rigid, so the current inflates it, and the current makes it turn. And that's one thing. The ocean bobs. There's constant wave action. You've been to the beach. Do the waves ever stop? No.
Yeah, I mean that's a natural power source right there. You can harness it.
Yeah, 200 feet offshore, where the water's around 15 to 20 to 30 feet deep, you put these little bobbers on the bottom, and as they go up and down, they generate a tiny little bit of energy. But if you have 1,000 of them all along the shoreline, you're generating a huge amount of power, and it's minimally invasive. You can just lay it down on the ocean bottom, and there you go. We're getting power. There's just so many ways. That's just the ocean. The ocean's, generates so much motion the ocean and its motion. Hey, I like that. Generates so much potential power. And then, of course, there's the wind power and solar. Solar cells are not really that efficient yet. I mean, at most, they're like 40-something% efficient, which means only, say, 42% of the sun's energy that hits it's actually converted into electricity from the solar cells. But that will get better. That'll get better eventually. And, when we look at the energy structure and the energy possibilities for us, we have to take into account that all these alternatives can supply the needs of the whole United States and the world. We just have to collectively say, okay, let's make this, whatever this technology is. Now, fusion is very promising as well. And I know that people say, oh, we're almost there. Well, fusion isn't easy. Fusion is how the sun works, okay? Hydrogen atoms, the fuel of the sun, are compressed under high temperatures and pressures in the core of the sun to make a helium atom, basically. That's fusion, okay? 2 hydrogen atoms become a helium atom. That fusion process liberates a huge amount of energy when you push those things together. And when that happens, that energy is really something that is much cleaner than fission, which is what we do now. Splitting atoms is not the same as combining atoms. With fission, and I think many people know this, with fission, after Chernobyl in the 80s and Fukushima just a short time ago, right? These fission reactors were actually their safety mechanisms were compromised. So the Fukushima, for instance, to stop that reaction, we had to lower control rods down in between these reacting strands of fissionable material. those control rods block the reaction, and that's how they meter the reaction. These control rods either go down and come up. And when they scram a reactor, that means sending all the control rods down in to shut it right down. Now, those control rods, okay, block the reaction, which is always happening. So they just block one rod from interacting with another rod of fuel pellets. And when you can't push those down in there for some reason, then you can get a runaway, and that's what they call the meltdown, as you know. Well, I liken fission to being in a deep valley. It's a reaction that occurs in a deep valley. To get that reaction to stop, you got to push it all the way up to the top of the valley and get it over the top, okay, and get it out of that valley. That's putting the control rods down in there. And that takes energy to do, and it's risky. Fusion, on the other hand, the energy that powers the stars, is like being at the tippity top point of a mountain. The slightest imbalance to that reaction doesn't cause a meltdown, doesn't cause a problem, doesn't cause a nuclear leak or a nuclear incident. The reaction just shuts off. So you have to keep balancing the reaction. It's harder to keep fusion running, because if you're not watching it, it'll just stop. Fission, on the other hand, if you're not watching it, it'll run away and, well, cause a meltdown. You know, and then we don't want to see. So there's the difference. So we found fission. Okay, fission came upon us because of of our exploration of the atom and the Manhattan Project. But if anything Niels Bohr did for us in his atomic researches, he actually was able to show us how atoms react at different energy levels, and we actually saw how fission's very efficient under certain circumstances. But if you look at fusion, on the other hand, that reaction is harder to contain, and it's harder to keep it going, which is why it hasn't happened yet. Fission, that's all over the world. You can probably have a fission reactor in your Coke can if you want to, you know. But you can't have a fission reactor because it's illegal, right? But fusion, I suspect, we'll be able to have, powering our house. A little tiny fusion reactor can power everybody's needs. And we'll never have to worry about generators, never have to worry about power outages, and also never have to worry about a power grid. Overhead wires, how primitive.
Right.
A solar flare can knock out New England, right? Or Pennsylvania, where you are, or Miami. And then Paul will say, oh my gosh, I got great viewing, but I don't have electricity to power the clock drive to follow the moon.
Yeah, exactly.
So anyway, but that's sorry about that. It was sort of long-winded. I hope that wasn't so. No,
not a problem. Not a problem. Okay. But the one thing, we're going to bring up two subjects that are kind of that are brought up a lot here. And the first one is going to be the old famous lunar wave. Now, yeah, a lot of other channels have claimed to catch this. Well, they have caught it. Whatever it may be. We were able to recreate it. So we just automatically throw it off as debunked. There is I'm pretty sure a lot of people in here have heard of Dazza the Cameraman's YouTube channel, and he was able to easily recreate it as well. What are your thoughts on the lunar wave?
If I'm recalling what the lunar wave was that sort of like this appearance that there was like a wave moving, not like a wave, but a ripple moving across the face of the moon?
Right. And at first, when it first came out, a lot of people said that the moon was being projected. So it was a ripple in the projection. And then, a lot more people jumped on board.
I actually, when I first saw that, I actually, I just finished telling you I'm never dismissive, but I was actually dismissive of it because I figured it was probably a camera issue. And a synchronization issue with the camera, and the way the camera was recording the scene. I actually didn't know really what the wave was in particular, but I figured it was probably just a camera artifact.
Right, and we did it basically for the ones that did catch it early on. Now this is not one since that had been caught since then, but the one that was caught, the guy was lives literally 20 miles from an airport. So it's, obviously that, but the little thing that not a lot of people realize that could actually cause that wave is micrometeorites too. If that comes down, either side of that, of your viewing of the moon where you have it in sight, those could cause ripples in the atmosphere and send them across just like a plane would. So there's plenty of things that could cause it.
Yeah, like the turbulent air left behind by a jet wake or something could actually slowly move through a field and look like a weird thing passing in front of the moon. I could see that.
Right, and those jet wakes, they can run hundreds of miles as they split in a V out the backside of a jet. They can go for a
as
really
you
long time.
as you know, when you're flying in a jet and suddenly you hit this turbulence at 33,000 feet that shouldn't be
Yeah.
there, and it's just because you're now traveling in the wake of a jet 27 miles ahead. Yes.
But also, the one thing that not a lot of people think about is if you're viewing on a nice clear night and all of a sudden you get this massive lunar wave, that can also be the jet stream crossing over your area, causing the turbulent air. It might be a little thicker,
Yeah,
might
I
be
mean,
thinner, depending on what it is. But there's too many probables involved with it to associate it with a projection per se.
yeah,
But
and there's plenty of reasons to actually uh, uh, discuss it as in terms of an atmospheric phenomenon too. And when a front moves in, sometimes they're very sharply defined. And sometimes they're not. Sometimes it's very gradual. Sometimes they're sharply defined. And where they're sharply defined, maybe the air is a little bit denser there, and the effect they have on the atmosphere is that they may calm the atmosphere more. Warmer air tends to be more turbulent. Cooler air is a little more stable. So if you have a cold front against a warm front, and they're fairly well sharply defined, as one front moves through, you may very well see that difference visually. Just as a submarine traveling underwater knows how to use thermoclines and get below that water level that's actually a little bit chillier, and that changes the way sonar signals bounce off. So if they're being chased, they can go dip under a cold water layer, and suddenly that signal is lost, and the enemy sub no longer can find you. I mean, we make use of the changes in the mediums all the time. So the air medium is another one. Now, if it isn't a camera artifact, then the only next thing is, as you were saying, the atmosphere. That's the only other thing that it could be, because it's certainly not the moon itself. Clearly, the moon is there. We have a tidal bulge that proves it, and tides that prove it. And I don't think they can simulate the tides, quite frankly, with their little projections. So they'd have to harness gravity, and that's just a little crazy.
And the second thing is, we might as well just go ahead and get it out of the way now. Flat earthers. Because I've seen we had a couple in the chat already tonight, so we might as well just go ahead and tackle this right now.
Well, okay. Yeah, I want to say something too. Amanda Curran is listening, and I think she's in the chat too.
Yep.
And Amanda is someone who I actually didn't know until tonight. She actually managed to wrangle me into a flat Earth debate a couple years back. I had just landed in Los Angeles for a conference, and Amanda was furiously, frantically trying to get guests lined up, and so she got Nick Pope and myself. And Nick and I were in the same conference, and we're sitting in the conference room together and talking, and we ended up doing this. But I remember that, and so she sort of apologized because she doesn't, she thinks that maybe she did something wrong. She didn't. It's okay, Amanda. But the bottom line is that, I have people writing me and calling me all the time, trying to make their case for a flat Earth, and all I do is I just refer them to the high definition Earth viewing experiment by the ISS. The high definition Earth viewing experiment for the International Space Station. That program shows the Earth from space live.
Oh, but that's NASA. That's fake. That's government run fakeness right there.
Right. And I was watching a live feed while the astronauts were changing some nickel metal hydride batteries. An older battery on the ISS yesterday, and oh wait, I just saw in chat. No, Amanda's not a flat earther. No, don't start accusing her of that. That's not nice.
I'm going to just for the hell of it.
Yeah, right. And I watched this live feed, and I saw some of the comments flying in, and I was just laughing because people were saying, "That's fake. That's fake. They're in a water tank. They're in a water tank." And it's like, yeah, but what people don't understand is inside a water tank, anything that you're using still has weight and mass. It's still going to sink when you let go of it, okay? And, the guy's holding this pistol grip tool that weighs around 12 pounds on the Earth, In a water tank, it's going to weigh a little less if it's somewhat balanced, but it's still going to gravitate toward its heavy end when it moves. All right. And this thing wasn't. It was just flying around and just flopping at the end of the tether. So, you can't simulate. A water tank is not good enough, actually. They'd actually have to have a full, true anti-gravity fakery chamber, and that's what we'd have to call it, an anti-gravity fakery chamber, to actually fake the NASA stuff. But I don't know. It's like what do you tell the people that lost folks on the Columbia and the Challenger? Do you tell them that they're not really dead? They didn't really die in these disasters, or were they all killed because they knew too much? They like to seize on that one too. I read the Columbia disaster report cover to cover. It's a really morose reading, and it's horrible to think about what those astronauts went through in those last moments. So, and I think that when people start to say that it's all a lie, that's the biggest insult to everyone who's ever lost anyone on the missions. And I don't, I don't really tolerate them, but I understand the confusion, and I'll explain it. And if they just want to just negate and continue to just press their point,
it's one of those things where they bend the facts to fit their beliefs instead of adjusting their belief to fit the facts. But and I do truly believe that a lot of flat earthers just do it just for the sake of being contrary.
Oh yeah.
It's almost like you just can't take them seriously. But it's 2017 now. I mean, if people want to believe in a flat earth, I mean, feel free. The same thing with religion. Just don't try to make everybody believe the way you do.
I always say this, and the flat earthers don't know how to respond. I say, well, if we have a flat earth, then, never mind the fact that physics abhors a flat surface, okay, and that physics won't like it, and that the basic shape of the universe is the sphere. Okay, never mind that. Let's assume you're right. How come in all of history we don't have any reports from people living at the edge who looked over the edge and said, holy crap, there's nothing there? How come we don't get that? We haven't heard any of that. We haven't.
Not only that, but not one flat earther can tell me the end game. Like, why? Why would this be a conspiracy? Like, what's the point?
Yep.
Like, there has to be some reason why they're keeping it a secret. If it is a secret, what's the end game? Right. And nobody knows. So it's like, I don't know. Yep. But we spent enough time on that flat Earth. I just figured we put it out there because I seen we had a couple of flat earthers in the chat. So
it's okay. I mean, all you do is look at the moon to understand why it's not. I mean,
not only that, but anything over 100 miles in space forms a ball. It's its own gravity. It's its own, but
that's right. But again, like I said, when you're science free, you can make the facts fit anything you want. You can make it. You make up your own rules, and that's what happens here. That's okay.
That's great.
Yeah, but look at the moon. The moon is spherical, and the other night actually, when the moon was still a waxing crescent, so it was just coming up to crescent, I took some photos of it, and I photographed the side of the moon that was in the dark. But I photographed it and I exposed for it, and so I have photos of the moon that kind of look like an underexposed regular moonshot, and the light that's hitting that moon to illuminate it is actually the Earth itself. It's the Earth shine, it's called. It's a reflection of the light of the Earth itself, which is lighting up that side of the moon. And that's just beautiful. And so because people can see that the moon is truly and clearly an illuminated ball, then you have to wonder, well, does that mean that the Earth is a ball too? I mean, how could the Earth be flat? If the Earth was flat, we'd never see the moon in the daytime, would we?
Oh, they have explanations for everything.
Oh, I know. I know they do. And again, when they want to ignore science, I guess they can explain away everything, right?
Yeah. I mean, that's how it is. But once again, it comes down to testable evidence. And it's just just the way it is. And Heidi had a question way while back that I wanted to bring up. She said something about boot prints not matching on the moon during the Apollo missions. Something about one of the boot prints didn't match the actual imprint on the moon. One was flat and the other one had some kind of grip. I think that's what she was talking about. I just seen it earlier and I kind of gave it.
I actually don't have I don't know about that, but I do know that in my lunar soil simulation I made, I actually had little tiny astronauts. Okay, and I made prints just to make sure that I could get prints. And it worked. But I noticed also that the boot prints weren't all identical with the same tread on the bottom of the shoe. I mean, it didn't all show the same way. And so there is variation, but I think that depending on the angle of the camera and the lights and the way the picture was taken, under, overexposed, you could actually get a different looking boot print. So I'm not sure. What the issue was there, but I mean, it'd be fun to see. I mean, I just don't know what the issue was.
Yeah. Yep. Let's see. I'm trying to look back on some of the questions that were in here. Sorry for skipping over you guys too. We kind of got caught up there. Oh, let's see. Oh, wow. Paul's got a good shot going right now too. Wow. So, okay. Well, there's another one. Might as well bring up Nibiru. The tons and tons of Nibiru channels all over YouTube.
Yep.
What are the chances that a rogue planet is going to come in and smash us to smithereens, let's say Thursday? Because it's always incoming.
Well, yeah, it's always imminent, when you talk to these folks, I get it. The chances are actually slim, and here's why. Now, obviously, everybody probably knew that, but the reason it's slim is because whenever there is a large gravity well, that is to say, a large planet that's interacting with other planets in our solar system, we can see that, we can detect that. And the orbits are very, very specific. Planets orbit in a specific way, a well understood way, that and these are called resonances. It's a resonance, the way they orbit. For instance, Mercury goes around the sun once every 88 days, but its same faces the sun, so it rotates once every 88 days. That's the tidal locking thing we talked about. Okay, now moons of Saturn. Okay, some will go around Saturn once or twice exactly in the same time that it takes one or the other moons to go around just once. All right, that resonance is set up through billions of years, basically, of the moons settling in to their final orbits, some ejected, some captured, and being subject to the physics that we're talking about here. And so when you see something like that, where you see a resonant orbit like this, you can see that you get the positional information the same time you look at it, year after year after year. It'll be here, it'll be here, it'll be here, it'll be right in the same place. You can predict it, and it's right on the money every time. Now, if a large object, another gravity well source, that is a source of gravity, comes into the solar system, then all of those preset values would be off. And we would recognize this and know this. And there's active programs now that are always tracking solar system objects and Kuiper belt objects. Now, Kuiper, which is Kuiper, that's actually pronounced Kuiper. The Kuiper objects might have very large objects in it. Some we already know. We know about Sedna. We know about Eris. We know about Keor. These very large objects that are out well past Neptune, and they're called TNOs, as in trans-Neptunian objects. These TNOs can be big, and in fact, because of what we see and how the planets are reacting, we think that there is something else out there that may be at least Earth-sized, that's out there in that Kuiper belt in its own stable orbit for now. And it's not a rogue, and it's not coming right for us, as in South Park, it's coming right for us, okay? It's not doing that, but it is out there. And is it something we have to worry about? Well, there may come a time where such a planet may be perturbed, out of its orbit. And if it is perturbed out of its orbit, it could end up coming down and making its way to us. But it would take it probably tens of thousands of years, if not millions of years, to actually get here. And so that kind of thing is not on the table. And if there was something coming right at us, or something that was on the other side of the sun symmetrically such that we couldn't see it, then we would know it. We could sense it. We could detect it. And let me just put it this way: there's no extra gravity floating around in our solar system, so to speak.
Right.
No extra gravity. We've accounted for all of it in that way. And the part that we don't account for really is something that is out in the Kuiper Belt. So these objects are still up for grabs. These
But I
objects we
should
don't know a
mention,
lot about yet.
those Kuiper Belt objects are actually probably going to become a lot more visible as soon as the James Webb Telescope is out, because that's actually, I think it's going out past Saturn, correct? It's where it's going to be orbited at.
James Webb Telescope is going to be a really cool, system, a great tool. So is TESS, the transiting exoplanet survey satellite. TESS is going to be great too. TESS is replacing Kepler, and that's going to be a beautiful helper for us too, because then we're going to be able to detect atmospheres around these planets, and that we can find. That's going to be amazing, because that takes us to a whole new world. We may actually find the real other Earth that way.
And I'll tell you what, Amanda had a good question, and I wanted to make sure to get this in. How is the International Space Station surviving when they tell us that there's loads and loads of space junk flying around out there, not to mention micrometeorites and whatnot? How come we don't hear of more collisions happening with the International Space Station, even if they're minor ones?
Well, I mean, first of all, a collision has to occur because of a vast difference in speed. And at the particular orbit that the space station is sitting at, other objects in the same orbit are going to be going at the same speed. So you're not going to have to worry about that. And they're going to be going the same direction because they're launched in such a way that they go into an orbit in the same way. All right. So we're not going to see them coming at us at 17,500 miles an hour while the station's heading toward them at 17,500 miles an hour. Okay. So the reason we don't actually get collisions is because, I'll make it easy. We were being very careful. We're careful about where we put these things, because we do have tens of thousands of pieces of active space junk and maybe up to 1 million inactive. I say 1 million, and I'm not kidding. Everything from bolts, from fragments of rockets that blew up in orbit and didn't return to the Earth's atmosphere. They're in very odd orbits maybe. And we know all this. We know about all these things, and we do track these things. Now that's quite a feat to be able to track a bolt in Earth orbit, but we can do it, and that's the kind of thing that that prevents us from seeing collisions. In the same way, how come the space shuttle never had a collision? Well, you could say that it didn't, and be okay with that, except that it actually did. The space shuttle did collide with some things now and then, because the space shuttle was exhibiting great changes in velocity itself as
Right.
it was entering orbit and then deorbiting and coming down. It could strike objects, and there were pits in the windows where it hit something. We don't know what that something was, but the velocity wasn't high enough to cause the window to just totally explode or whatever.
Right.
But so if you think of it as like a bowling alley, each bowling alley has its own set of pins, its own ball that goes down that alley. Those balls, from one alley will not collide with the ball of another alley, and the pins won't fly into another alley. But now and then, if you throw a bowling ball hard enough, you could actually accidentally skip out of your lane, right, and go into another lane. So,
Yep.
and I liken that to a catastrophe where a satellite has a thruster that gets stuck and it starts going into a higher orbit, and then maybe it goes highly elliptical. Now it has to be tracked because it could end up being a very dangerous prospect for the future. Now, the ISS actually has a limited lifetime in space. It's going to be deorbiting sometime after 2025, and that's going to be quite a burn coming down into the atmosphere. So maybe the Russians will take it over, but you have to understand that the reason why it will come down at all when it's just to be orbiting nice and gently up there is it's 251 miles up, and solar activity changes, and as the sun gets active, the atmosphere of the Earth expands. It gets active, and these activities cause the atmosphere to expand and to contract,
Yep.
expand and contract. And so maybe sometimes at 251 miles, it's feeling, 2 or 3 atoms of atmosphere, 2 or 3 molecules of atmosphere hitting it every now and then. But when the atmosphere is expanded and excited, maybe it's getting 20,000 atoms. over time, that induces some drag, atmospheric drag, even at that altitude. And so eventually it's going to come plummeting down unless we have a way to burn some fuel and put it a little higher again.
Well, not only that, there's everything like satellites, the International Space Station, all that stuff is falling towards Earth. I just wanted to make this clear for people in the chat. They do have to reposition those every so often, where they have to lift, the ISS up, back up into its orbit, because the gravity from Earth is just constantly pulling stuff in. That's why they have, they have to readjust satellites, take them higher in orbit, because everything is constantly, as it rotates around the Earth, it's constantly coming towards the Earth, and they have to fix it. So
yeah, and that's the concept of an orbit. You go horizontal speed enough so that the pull from the Earth is negated by that horizontal speed. This means you end up traveling in a circle around the Earth at the same altitude. So you're constantly being pulled to the Earth, and that is why you keep going in this circular pattern, the circular path around the Earth.
Is that what's related to escape velocity?
Well, it's related to orbital velocity, but escape velocity is when you go a little faster than that. If the space shuttle was going 17,500 miles an hour, it would have to go, and that would put it in orbit 151 miles. Well, it can orbit out at 22,000 miles, which is around the geosynchronous location. It could orbit that far out at only about 8,000 miles an hour. Okay, so escape velocity from that orbit is a lot lower than escape velocity from a regular orbit like the space station is at. So it's a matter of how well the telescope is spinning like mad now. What the hell's going on with him? Paul's having a conniption. The whole moon just spun around. I think it's real.
That's him rotating the camera.
Really spun. Yeah.
But all right, I want to get some questions from chat, just to make sure I get everybody that wanted to ask a question.
Sure.
We have let's see.
And Amanda, that was Amanda's question. I forgot. She told me earlier she was gonna that I should be reminded to answer that, and I forgot. I'm sorry.
Of course, I hit one button and then lost a question. It was from Jay Rich.
Okay.
And of course, it was a while back now. Sorry, Jay, I lost your question. I had it here, and then I accidentally hit the down button. There it is. All right, Mark, it's a question for you. Do you think it is possible the universe is collapsing in on itself rather than expanding, like two cones put together at the small end?
Well, that's a good question, because for a long time we had three ideas. The universe was expanding forever. We had the idea that the universe would go out and then would come back, and we had the idea that it was steady state. I mean, those three governed a lot of astronomy in the earlier days. Nowadays, though, we look at it as saying, from looking at imagery like this, looking at the moon, we can see that there's been a long, tumultuous history to the universe. And it hints that there's a lot more complexity out there than we realized. And we've seen that. And now what we believe is that the universe is expanding differently depending where you are in the universe. And for instance, there's an area in space that looks like all of the universe is leaking out of a popped balloon. And it seems like the material at that region of space is racing out of the universe at a strange pace. And I say universe, and what does that mean? That means like it's leaving our known envelope of the universe, our known balloon of the universe. And it's possible that we're seeing something going to the next universe that's parallel to ours. And that's possible because for a lot of reasons, but for one reason in particular, two reasons in particular, that a bunch of studies several years ago showed that the universe, when it was born, created multiple universes at the same time. That is, parallel universes might very well be a reality. That was the postulate back then. Well, then a few years later, another study was done independent of the first, which confirmed that possibility and said, and by the way, we think we know how these parallel universes are actually laid out with respect to each other. And they provided a pseudo topology for this layout. So the question of whether it's expanding or contracting is sort of incomplete. You have to say, all right, if it's expanding, then why is it expanding? And if it's not expanding, then how could it be contracting? Is there enough mass so that it would actually start to contract? Well, it turns out that this expansion isn't really, well, it may not be, I should say, due to the original Big Bang explosion, because we discovered that it appears that maybe the universe is being pulled outward from outside of itself. And that's an interesting concept. And this is something that you guys, out in the chat, you can go look up some of these things to see for yourself. But the fact is, if the universe is being pulled outward, it's as if a balloon is being put inside of a vacuum chamber and the air being removed from around the balloon. The balloon will start to expand. That's effectively what's happening to the universe. The expansion is coming, it seems, from outside the universe. And that's what's weird. And the reason we think that is because this expansion is accelerating. It's not constant. It's accelerating. It's becoming faster and faster and faster every single time we measure it. That's the key. That's what determined for us that the universe, it's not expanding from the source explosion. It's actually being pulled outward at a faster and faster rate. This is bringing up all kinds of things like negative mass, negative energy, and realms of dark matter and dark energy, which are called dark, by the way, because we don't know anything about them, not because they're physically dark. So that's why they're called dark. It means nothing related to lightness and how bright they are. So when you look at that possibility now we're talking about a whole nother thing. We're talking about the fact that we only see 4% of our universe. Everything we've done is dealing with only 4% of our universe. Everything that Paul is doing with his telescope right now, 4%. Everything we did to get to the moon and walk on the moon, 4%. Every rover on Mars, 4% of the universe we knew about got us there. So knowing only 4%, we've done a heck of a lot for knowing just that amount. Now, once we can harness the other 96%, or some, say 2 more percent, 6% of the universe, and understand what this dark energy interaction is with the outside of our universe, that will change everything. We're somewhat primitive. We only know about gravity in the terms that it makes things fall to the earth. We know about the force of gravity. Hey, I can calculate it. Okay, GMM over R squared. That's the gravitational interaction between two bodies of one mass m, the other mass m something else, and those I can calculate the gravitational force between those two bodies. I can calculate the orbital speed required to keep us in orbit. I can calculate everything related to gravity. What I can't do is manipulate gravity. I can tell you how I can manipulate the ship so that it stays in orbit, but I can't manipulate the gravity itself. I can't shut off gravity. We can shut off light, we can shut off magnetic field, we can shut off electrical field. We can change all of those other forces in nature, electromagnetic wise, and we can't do that to gravity. It's the one remaining thing we can't mess with. So finding gravity waves a few years ago, very, very important step. Remember the 2 interacting black holes where they actually detected gravity waves for the first time? That was hugely important, because now that shows us that, what we suspected, gravity is of wave nature. Light's of wave nature, right? Okay. Right. So if light's of wave nature, and we know light is also of a particle nature, you have light waves, you have photons as well, particles of light. Light particles are massed. They have mass, although very, very small. But we proved they have mass because when we did the experiment by looking at the stars during an eclipse of the sun, you could see that the light from the stars was bent by the gravity of the moon. That showed us that light had mass. Okay, so all these historical experiments just showed us tremendous, famously tremendous data that helps us realize that the universe is something we don't understand yet, but we're getting to it. And gravity, we can bend light, we can stop it, we can, like I said, but we can't do that with gravity yet. We will. Now that we have gravity waves, we've seen them, we kind of understand a little bit more about their nature. Now we can go after graviton, particles of gravity. Does that have mass? I don't know. Maybe it does. Maybe they don't.
And this science is moving at a tremendous rate. We're literally learning more and more every single day. about it. I
Exactly
mean,
so.
just technology has just taken off in the last 5 years and just getting faster and faster.
Indeed, it is. Indeed, it is.
Amazing.
So I'm really happy with that with this. I mean, it's kind of a great time to be alive, because we see some of these discoveries like as they're happening, and they'll be read about, by historians in the future, just like we record about, just like we recorded about what Tesla discovered and what Edison discovered, and about their rivalry between each other, and we see it now as history to us, but and the people that were living through it, they might have had a different opinion because they had the privilege of living through that time, and we're living through a time where we're just now we're on the cusp to getting to Mars. I mean, that's fantastic. That's a great time to be. That's a great time to be around it. Just getting on the cusp of going to Mars.
Amazing.
Yeah, so I know it's a long-winded answer, but I'm sorry.
No, I can't wait. I can't wait. Well, my biggest thing that's happening this year is well, not this year. It'd be the beginning of next year is the James Webb going up.
Yeah.
That I can't wait for the images that we get back from that. That's just going to be apps. But everything has to go right in order for it to work. And what they're doing with it, with sending it out past Saturn and stuff, it's going to be a lot of sleepless nights for some NASA engineers.
Well, and for some of us too, who actually are going to be following it like very, very closely.
Yeah.
I mean, I'm very, very happy that the Webb telescope's going up there. There's a lot that's going to have to go right for it to get out there and in place. A lot.
But so worth it. So worth it.
Yeah. I mean, we had a number of probes fail when they tried to land on Mars. We had a number of probes succeed when they went to land on Mars. So let's hope that the Webb telescope at least has a chance of working right by getting into its location.
What do you think the next form of propulsion is going to be? Do you think it's going to be some form of the helium-3 that people are talking about on the moon?
Maybe, but you know what? I think that we're going to have a bunch of revelations here to come through to us, because we actually don't have a prospect of using chemical propellants for very much longer. I mean, we can use them, of course, but we're never going to be able to get past a certain limit to the amount of time it's going to take us to get to a particular place. We're never going to be able to get past that without, a new form. And maybe we're talking about using the EM drive, that microwave drive. It's a drive that actually works by using no fuel at all, but because of the geometry and so forth, microwaves end up getting created and shoved out the back end of the propulsion. Actually works. It's been confirmed to work. So, I mean, a fuelless rocket motor is kind of cool and sort of defies logic. Well, it defies physics too, but I mean, it defies logic, but it's really cool. So that's a possibility, but that one is not really meant to like send us up into orbit. That one's meant to take a probe long term and get it up to some high speeds. Maybe that will power the first interstellar probe. Trouble is, if it goes to any star system and you want it to get there as fast as possible, then you're not going to slow it down. You're going to just have it speed through the system. If that happens, it'll speed through the system and just keep right on going. It'll never stop. So if you want it to slow down, you're going to have to turn it around at the halfway point and have it thrust in the opposite direction for the same amount of time it took to get out to that halfway point to slow it down. So, that EM drive might be possible. I believe we're going to use chemical propulsion for the Orion system to go to Mars, because right now I don't think anyone is brave enough to consider other options at the moment. We don't have fusion yet. We can't create a fusion drive of any kind because we don't have fusion to do it with. But eventually, the advanced propulsion that's going to come our way might be in the form of the warp bubble, postulated in 1994 by Miguel Alcubierre. And that warp bubble is it's a bubble around the ship that would allow the ship inside the bubble that was generating the bubble to literally pull the universe past it as fast as possible, meaning that the ship would never have to violate the speed limit law of the universe, which is the speed of light. And that would allow you to pull the universe past it as fast as you can muster. To do that means that we could actually foresee and envision a ship that could get to the Alpha Centauri system, our nearest star system, 4.3 light years away, in 5 days.
Mm-hmm.
Now, there's a whole bunch of caveats to that. A number of them being that relating to the fact that as you're traveling through space at such high speeds, well, as you're pulling space past you, I should say, at such high speeds, you're accumulating a whole bunch of crap on your windshield, like bugs on your windshield kind of a thing, right?
Right. Yeah.
And just imagine, this is space. Those bugs consist of energetic particles. They also consist of atoms and molecules and dust and dirt and debris that's out in space. When you stop from the speed that you're traveling with pulling the universe past you, one of the caveats of this particular drive is that as you stop, all that stuff on your windshield is going to slough off with a very, very highly energetic explosion. And so you might go to Alpha Centauri and see a burgeoning populace there with a huge planet with lots of spacecraft going back and forth between other planets. And as you come out of your warp drive, you'll say, "Whoa, there it is!" Boom.
Oh, boom. Yep.
No, it ain't. And then you'll say to your other guy, let's just tell him nothing's here. Okay, yeah, just send the message back to Earth, nothing's here. Yeah, I see nothing.
Let me give you another question from the chat here. Which this question has come up a couple times. Why don't we see angular craters? The person asked. Like, it almost looks like every crater hit dead straight on. Shouldn't there be some kind of trenches or something that a meteor or a comet, scooted through the surface coming in on an angle?
We do see those, though. There's actually a number of chain craters which actually show elongated, and they're elongated craters. If you look up on Google to the person who asked the question, that's an excellent question because it illustrates something about gravity, actually. If you look up elongated craters, you'll see that there are craters that form by an oblique object coming in at a narrow angle of attack, and then when it hits, pieces of it bounce and form several secondary and tertiary craters and more beyond it. All right, and those chains of craters, those crater chains are actually related to each other in many cases, and you'll see them when you look them up. They are elongated because the objects did come in at an angle. But what we're seeing here, again, remember, is from the era of bombardment, where it's early Earth, early Moon. And particles and objects of any substantial size, when they came toward the Moon or the Earth, they were heading straight for it. So wherever they were coming from, they were heading right for it anyway. So they would hit straight on most of the time because there was plenty of space, so to speak, between the object and the target for these objects to realign their path and just come straight down toward the object. And that's just what they did. And that's why most of the craters you see are kind of round. There are some elongated craters, though, and I encourage you to look those up and look for them because those are relatively rare, but they are out there. But that's a great question.
Yeah, I thought so too. Any other questions in the chat? Mark was here for a little bit longer. I definitely want to get to any question. I know there was probably a tons in there that I missed. I was kind of caught up in listening and imaging the stream here. And once again, Paul, if you're listening, great job tonight. As
really
always.
Nice, Paul.
Yeah, awesome stuff. Even with it being humid down there. I know somebody had asked earlier that is it like looking through water? Well, in a way it is. If you have humidity, you kind of are looking through water at some point.
That looks like Gassendi crater. Is that what he's looking at right now?
You know what? I wish I've been studying moon maps, and I still can't remember half of them.
Okay.
I've been trying. But
cool,
I mean, even to this, but I do know my favorite area. Yeah, my favorite area of the moon by far has to be Aristarchus, because Aristarchus is, like I've told everybody in the chat, it looks like somebody just took a square patch of like a planet somewhere and literally just took it and placed it on the moon. Because you know how it has that kind of like that square fenced border look to it? That it's just my favorite part. And with the deep ravine that's running down through it, and then of course the crater itself. It's just it's an amazing area, and we should see that on the waning side.
Yeah,
we'll concentrate on that pretty well. But Let's see what we got here. Chat is going. I don't know. Have you seen any questions in there, Mark? That I missed?
No, but you know what? I mean, we could. I don't know where you want to take this. We can go almost any place with this stuff.
Sure.
I mean, we were talking about how craters were formed by multiple means, and how some look like just regular little bowls. Those are the simple craters, and the complex craters like Copernicus and so forth have the central peak we talked about. But what's interesting is, I think when you look at some of these craters, you can actually recreate these on your own, even the ray structure of the craters. And if you've ever seen those sand sculptures where people put different colors of sand at different levels in a bowl or whatever, and the top layer is like this one color, and then underneath that layer is maybe blue, and then that's red or whatever. Mm-hmm. You can create literally a demonstrator to show how lunar craters form using those types of materials. And I use my sample soil for this, actually, my sample lunar soil that I made all the time for this, for presentations. You actually lay down this material, and on the very top layer, you lay down some talcum powder, okay, which is like white. All right. Now, if you take a little piece of clay or a marble or something, whether it's oblong or whether it's just round, and you drop it from various heights, it simulates an impactor hitting at different speeds, and it produces different energy. And you can actually literally create lunar craters and watch a crater formation process that's it's distinctly different, obviously, because it doesn't pulverize and make the surface molten, but it does create the very same kind of crater mechanism, and all of the material that's under the surface that you think is not going to end up splattering out. You might see that the top layer is yellow sand, and underneath it, say you have a blue layer, you'll see that you have blue rays. Hey, Blu-ray, that's kind of cool. We should make a CD or DVD like that or something.
There you go.
And you have craters with blue rays sticking out of them, okay? And you'll actually see that that's kind of interesting how that happens, because the top layer is kind of shoved aside, and the underlying layers end up getting pushed through at higher velocity. Really neat. So you can actually generate different kinds of craters this way. You can do this as a school project, too. You can do this to demonstrate. Kids love making a mess. And I used to take this to schools all over the place and do lunar craters. It was a blast, because I would give out little bins to everybody and give them little soil. Not my particular soil, because mine was pretty costly to make. But I would give them flour, and they would use flour, and they would use another material like a talcum powder, and we would actually make our lunar craters. And it's just so cool to watch it happen. So you can actually create your own craters. You make your own cratering. You can even get, if you do it right, you can actually get a complex crater. You can actually make a central peak, because the thing you send into there, into the bin, if it goes fast enough and hard enough and goes deep enough, then it'll get buried. And when it gets buried, the material comes back from behind and whoop, makes a little central peak once again. Very cool how that all happens.
Right, which brings up another question that somebody had asked, and we kind of covered it earlier, which is, why do so many craters seem to be flat on the inside? Like big flat areas.
Yeah, that's actually related to what happens when the cratering process occurs. Most of that flatness happens right after the initial crater is created. So within at most a couple hours or so. And the way that happens is when the crater is splashed out, like you see when you see Copernicus. We don't see that now on the feed, but say with Copernicus, where it gets splattered out, huge amount of cratering, there's a huge hole that's created. And there is really a big transient crater created, a big giant hole that's created momentarily as everything is melting and pulverizing. But then that stuff starts coming back. And when it comes back, it tends to want to settle out. And when it settles out flat. So
think about doing a cannonball in a swimming pool. Something has to fill that. Not only do you get the central uplift of the matter, but eventually everything has to flatten out.
That's right.
Is that kind of a good analogy?
Yeah, actually, no, that's a good way, because you're thinking of swimming in the freaking 17 degrees, man. That's okay with me.
Yeah, my mind is there.
Yeah, you're right. You're in the Arctic. Yeah, you're in the Arctic, man. Get that mind out of that. Get out of that tropical gutter, will you?
Yeah, and we also have a question from Allison Aurora, which is the moon is moving 2 centimeters away from Earth each year. How can it do that because of Earth's gravity should keep it in?
Well, actually, that's actually a conservation of momentum question. One of the problems is that uh, as the Earth um, as the Earth is turning, um, our day used to be a lot shorter, and it that meant the Earth was spinning faster. Well, as the Earth slowed down, okay, that there's a dance between the Earth and the Moon that takes place, and some of that momentum, that angular momentum that we had spinning, gets translated to an effect that affects the Moon. And so the Moon, as the Earth slows down, the Moon will drift a little bit farther away. Okay, and that kind of it's a holdover from when we first form. And I think that's sort of a neat question, but hard to actually demonstrate that without actually having a little rig to show you. I mean, if we had video in our call at some point, if we could throw video in, I could actually do little demonstrators at some future point and show how that stuff works. Um, you know, um, in angular momentum, you know how that works, okay? When a skater puts their arms out, they spin slower. When they pull them in, they spin a lot faster, right? So that right there is that angular momentum issue right there is something that the Earth and the Moon had between themselves, between each other, as they were orbiting. And so the Moon will pull a little bit farther away from, over time. It doesn't mean it's going to eventually leave, nor does it mean the Earth's going to come to a stop. All right. It just means that we're going to reach that point where, the Moon and the Earth reach a stabilization, and we haven't yet. That's kind of interesting, but again, it's all part of the orbital resonance that is responsible for the planets staying where they are, the Earth staying where it is, and so forth.
Are you a fan of? Are you a fan yourself of the privatization of space? You think it's a good trek to go on, or no?
Oh yeah, I do. I really do. Absolutely. Yeah. Absolutely.
The only thing that worries me about it is people attempting to claim instead of by country, by individual, which shouldn't be claimed by either or. What I was thinking about that is,
but that comes with the territory. If you really want to see us exploit space and become lunar and Mars colonists, then you gotta open it up to business and let them go for it. Let them be the ones to go for it. And whenever government tries to do something, we know how it comes out. It turns out that government tries to do something that won't offend anyone, and that won't hurt anything, and won't cause any problems. Unfortunately, to progress, well, there will be people that aren't happy. It doesn't mean that we're gonna pillage the Earth for all its resources. Of course not. But we might find, for instance, some reticence to say, go to Europa, Jupiter's moon. Jupiter's moon, Europa, has an ice sheath over it, but underneath that ice sheath, we think there's a deep ocean, probably maybe 100 miles deep. That ocean, it looks like, might be very well oxygenated. This we see from some of the geysers and stuff that we can see is similar to Enceladus at Saturn. But this ocean, if it's oxygenated, doesn't mean that there won't be life. It means that it might be very acidic. But because there's a potential for life, we don't want to contaminate any potential ecosystem there. So the Juno mission to Jupiter right now, that Juno mission gave us unprecedented shots of Jupiter's North Pole and South Pole, I believe. And the Juno mission, when it's done, is going to be purposely deorbited into Jupiter's atmosphere, where it will be destroyed. And they only did that for one reason. They did it, two reasons. The first reason is that they'll get some final data from Jupiter's atmosphere when the probe hits the atmosphere. But the real reason that they actually did it was because they want to make sure that any potential ecosystem on Europa isn't compromised by a chance collision with our Juno probe at some future point. So it's because they're forward thinking they actually didn't do it. So we have to consider that we have to tread carefully. If we want to go visit Europa and learn about potential life under the ice sheath, we have to be there, and to be there means we have to be taking certain precautions so as not to contaminate any life that's there. Correct? So, how do we do that? That's the hard part. We don't know how to do that yet. Are you still there? Crap. I think you're gone.
No, we're here.
Okay.
I was just talking and I didn't realize I had my microphone muted because I was typing something.
All right.
Yeah,
well then,
I have to mention we're talking about bacterial life, not like little green men, walking, talking,
yeah.
type. We just don't want to
Yeah,
contaminate.
but see, we're even there. We're trying to protect the microbial environment. That's right.
Mm-hmm. Yep, and then we do have a question from Duplicat in the chat. Does the Earth's magnetosphere cause static dust movement on the moon?
Not that we know of. I mean, I don't think that there's any. I don't think there's any possibility. I mean, static charges induced by frictional interaction with a medium like air. So I don't think that we have that happening on the moon, not at least with air. The only way that the moon dust gets statically charged was when there are charged particles in the lunar dust that are acquiring charge from the sun hitting it, and those charged particles can interact with, say, astronauts' boots and cause a static on the astronauts' boots, which cause a lot of dust to get in all the nooks and crannies on the spacesuits.
Mm-hmm.
But that's about it. I don't know if there's any reason to be concerned that the Earth would actually cause the dust to move on the moon.
And so Countess Capital asks, does chemical spectrometry interfere with your imaging when you guys are studying light refractions around the moon?
I don't. I'm trying to figure out what the question is that's being asked. Does chemical spectroscopy cause any problems?
So does it interfere with your imaging when you are studying light refractions around the moon? That's the question as it was written. Once again, that's more of a technical thing that maybe Paul would know more than I would.
Well, I'm actually trying to figure out what if the question is if I want to say it in a way that sounds bad. I want to see if it's a good question or not. I'm trying to understand if I can see if I can understand the question. I was looking for it in the chat. I don't see it in the chat.
It's probably way up there now. But the way it's worded, it just says, does chemical spectrometry interfere with your imaging when you guys are studying light refractions around the moon?
Okay, so I'm understanding. Maybe the question means spectroscopy.
That's what I'm thinking.
But that's okay. I mean, the answer would be no. But I can say this: you can see depending on the optics that you use, you can see optical effects that can cause the image to be really degraded in some cases, and especially where there's a area of the moon that's got a bright limb on it. You might actually see something called chromatic aberration, depending on the quality of your lens, the eyepiece, say, that you're looking at through the telescope with, or the camera through which you're viewing it, and the optics of the telescope itself. So the only interference with viewing the moon would be through something like that, if you are excluding all the atmospheric effects and the clouds and so forth. But beyond that, I don't think there's anything that gets in the way.
Let's talk about one of my favorite subjects, the space elevator. And I see Derek had brought it up in chat, and I'm going to use this as you explain maybe to people what it is if people haven't heard it before. I'm going to use this chance to actually take a pee because I've been sitting in this chair for so long. But if you want to explain to what it is and how it works and all that stuff, and then we'll go into is it feasible?
Yeah, but Countess Capital, I think, made a clarification. She said spectrometry caused blurs in the imaging. Okay, that I can understand. And now we're talking about having, because light is made up of all different wavelengths of light, they focus at different places on the film plane when you take a photograph. That's why you might get some weird fringe coloration on some frames and so forth. Well, I would have to say that the answer to the question is it depends on the quality of your optics. You can get optics that don't or that do take into account that change in that level of focusing, and that they focus at different planes. You can get optics that will actually correct for that, and they are a lot more expensive as a telescope than a regular telescope, but they're worth every penny, because then you don't have any strange little rings of blue around a star or something like that. It actually looks pretty nice. So now I understand the question more. So I hope that was helpful. And then as far as space elevators,
thanks for clarifying too in the chat. Thanks for clarifying that.
Yeah, thanks. Yeah. So you're talking
space elevator.
All right. Well, the concept of a space elevator seems simple enough from the outside. You have a rigid construct like a tube going all the way up to orbit, and you make this an elevator that you can just go right up and send equipment and space people up there and say, hey, what an easy way to get to space. We just have to run an elevator. Well, the problem with the space elevator is that the space elevator is not just going to be able to go up to regular Earth orbit like where the space station is. It would have to go a lot farther out. The reason is because at the rotation rate of the Earth, you'd have to make a space elevator that can go all the way out to the location in space that would stay over the same spot on Earth as the Earth rotated. Well, that location is the geosynchronous location, which is 22,000 plus miles out. Now, all the way down that length of that space elevator, gravity from the Earth is still pulling and tugging on this tether, this elevator. This is going to cause major forces to be incurred on this giant elevator. That could cause a problem. In fact, the elevator could not, with any known materials that we know of, the elevator would not hold together. It would disintegrate. It would fall apart. It would break. So we don't have the ability yet to make an elevator up to geosynchronous orbit. But don't mistake now. It would have to go all the way to geosynchronous orbit. It can't just go up about 250 miles, because it would have to be freestanding at 250 miles, all right? Or we would have to put something in orbit that could continue up to geosync and hold it there. So this concept is really still a far future concept because of materials. We don't have materials that can withstand, the stresses of being put under that much gravitational pull over the full length of such a thing. So That's the only reason that we can't have a space elevator now. And I love the concept, because it would mean, hey, we just have a nice cheap way to get to space, except that space elevator would probably cost more than 3 or 4 space programs combined.
Easily.
To make it.
Easy, but the amount of money that would be saved from not having to launch, liquid fuel rockets would pay itself back in the first, 50 launches or something like that?
Well, maybe. I mean, if you look at it, but again, it has to go all the way to geosynchronous orbit. It can't just go to regular orbit, because it would still have to be traveling at orbital speed, and if you just went up to, say for some reason you could create a material that could withstand being brought up to 250 miles, and you had a freestanding pillar elevator shaft 250 miles tall. Okay, that's about the height of the space station. So now you say, okay, great. So now let's get up in the space station. Let's bring this thing up the elevator. Let's go bring these supplies up for the space station. Well, you bring these supplies up for the space station, and then when the space station came around, it'd go whizzing by you at an unbelievable speed, because you're not traveling at but the speed of the Earth's rotation, and the space station's going 17,500 miles an hour, and it's going to go whizzing past you at an amazing speed. So you still have this great delta in velocity that you'd have to make up, and that's the problem with the space elevator. You can't. It'd be good if you could to get stuff to geosynchronous orbit, but to get stuff into low Earth orbit, space elevator wouldn't work. because the top half of the elevator has to be moving 17,500 miles an hour to match whatever has to be in that orbit, and that means that the whole thing would bend, twist, and stretch, and it'd be gone in like split seconds. So
then,
that's
if that's the case, like, why are people still pursuing it?
I can't tell you. I can't tell you. I mean, I guess because in terms of a intellectual pursuit and an esoteric way to get anything up into space orbit, we could pursue it as far as getting to geosync, to getting to that geosynchronous or geostationary orbit, but we can't really put something in orbit and go up to just like shuttle orbit or ISS orbit. It wouldn't work because we would be only moving at the speed that the Earth's rotating, which is far less. The Earth is not rotating very fast relative to a space station.
Yeah, I love the idea though. I love the out of the box thinking that it takes to come up with something like that.
Yep. I mean,
even if it isn't geosync, would it be possible to even take fuel to geosync and launch something from there with liquid fuel? That would save.
Well, now if the elevator was already paid for, and now we're just using it to get stuff up to geosync orbit, escape velocity from geosynchronous orbit is much lower. And so it's a lot cheaper and a lot easier. And sure, we could just keep bringing elevator car after elevator car materials up there, and have a little space station up there and build a spacecraft and just send it right off. I think that'll be wonderful.
Be sweet.
So, yeah. But Earth only rotates around 1,000 miles an hour, and of course that's the space station would travel by you at 16,500 miles an hour more. Right. So you can't say, "Here you go, guys." Oh, they missed. We'll see them in 90 minutes.
We'll get them on the way back.
And we'll get them in 90 minutes when they come around again.
Holy moly.
That's cool.
That is awesome. So what's on your calendars coming up, Mark? Anything interesting?
Well, I'm building my observatory, so I've got a large instrument I got to put in the observatory, and I got a second one I'm going to piggyback on it. And it's probably your damn fault. Okay, I've had this thing sitting in a box for a long time, about 4 years, and I finally, after watching one of the streams that you and Paul provide, which is phenomenal quality, I decided I wanted to start now getting my telescope back out there. So I set it up one night, and it's a big Meade 10-inch Schmidt Cassegrain, and I've got this 5-inch refractor as well that I want to piggyback on it. And to set those things up, was just like an hour outside in the cold, and it was like, man, I wish this was in a building in an observatory. And I have an observatory dome in the backyard as it is now, but it's not populated with anything. It's just the dome because it was given to me, and I ended up donating it last year to a school down in Tennessee, and I have to send it still. But they're anxious to put their 14-inch Celestron in there. And I'm going to get another dome, which is going to be a portable astronomy observatory building from SkyShed. They make these things called pods.
Right.
And
I was actually on the SkyShed website and looking around. They're actually pretty neat stuff they got on there.
Yeah, I'm going to get myself a pod for this setup,
Well, if you need any secondary imaging done, you know who to give a call to.
Oh, you betcha. Well, I'm doing it because I want to be able to put my instruments up there so that I can actually do spectra of the stars. Now, when we look at spectra of the stars, okay, let's take our sun as an example. If you look at our sun and you break its light into the red, orange, yellow, green, blue, indigo, and violet, the Roy G. Biv of the spectrum. Right. You'll notice that there's these dark vertical lines all throughout the spectrum of the sun. That is called the spectrum when you spread it out like that. And these dark vertical lines are in a particular place because that means something. That those dark lines tell you the chemical composition, okay, of the sun. And those chemicals you see, some have standard locations, like hydrogen has a specific set of lines that appear in a spectrum. You have the Lyman series, you have the Balmer lines, okay, the Balmer series, and then you have things like magnesium and calcium and oxygen and helium and other chemicals, because what's fascinating to me is that everything in our solar system, you, me, the planets, the moon, everything we see was once created as part of a stellar reaction in the heart of a star. So, the thing about our elements, when we look at the periodic table, everything in that periodic table, except for like the last 10 or so, was something created in a star. Now, up to iron, like number 26 or so, those are created in regular stars like the sun. Everything past iron and before the last 9 or so, or last like 96 or so, we're number 96. Everything past iron and up to element 96, those are created in supernovas. So it's funny to think that copper was created in a supernova, but it was. All copper that was in the veins inside the ore in the earth was all created in a supernova at one point. And when the earth formed, copper formed with it, because copper was here because of the fact that it was part of the coalescence and building of the original planet Earth. Very fascinating stuff. So when you look at a star and you take apart its spectrum, you can actually see what it's made of. And certain stars, like our sun, which formed 4.6 billion years ago, all right, in a 14 billion year old universe, stars like our sun have things like magnesium and calcium and oxygen and helium. A lot of other chemicals from the periodic table are already in the sun. The sun didn't make them. The sun had them from its origination. Mm-hmm. The sun is not big enough to make, all the way up to iron, but it can get to carbon, and it can make carbon. So it'll do carbon, do hydrogen, it'll do helium, it'll do carbon, okay? And then there's complex reactions, that in the fusion chain that you have to you learn about. But these reactions are how all these elements in our periodic table came about. And so we will, find that stars that are lighter than the sun might not make carbon. They might just stay with hydrogen and helium, and then when they end up using it all up, they end up going up to they expand into a red giant, and then quietly shrink down to a white dwarf. So they may not give anything back to the interstellar medium right away, but the bigger stars, the big, bright, hot, massive stars, the ones around which planets can't form because the radiation is too intense. Those are stars like O stars. They're the hottest and the biggest and the brightest. The B stars, those up there, those hottest, youngest type stars, those stars only live several hundred million years, as opposed to like the several billion years that our sun still has. So those stars, those are going to go supernova. And so any materials that they haven't made yet in their cores, when they do blow up, a chunk of the others are going to be made too and released into the interstellar medium. Can you imagine how much this had to happen over the 14 billion years for us to find so many planets around so many stars, and just to consider how much stuff we have here on Earth? Mm-hmm. All of that stuff was created in a supernova explosion, almost, beyond iron. So this is incredible. And so I'm building this observatory so that I can actually look at the chemical compositions of stars. And I have a system already to do that. I do it now. I can actually use a DSLR camera on a tripod and just photograph a bunch of stars, and I can see their spectra from that, and I can determine the chemical constituents from there. But with a telescope, I can reach and see dimmer stars, and I can look at things like planetary nebulae. Now, if the sun
what do you do with the stuff that you do gather, with the pictures and any kind of video that you get? Like, do you post that anywhere, or do you kind of just keep it for yourself?
Yeah, well, to this point, I've always just kept it for myself. But I write for the Huffington Post. I do I have a blog up there. If you look up my name with Huffington Post, you can read my articles, and they're thought-provoking articles. They talk about real science, and they talk about the stuff that we're discovering. I also have one up there called the Lunar Landing Not Hoax, okay, mm-hmm. which discusses everything we talked about today and more. And so there's a whole bunch of cool articles up there that I wrote that you can read. But you know, from my point of view, I'm going to take my research material, and as I get some good results, I'm gonna show it. I'm gonna publish it, and make it public, because everything I'm talking about comes from everything I've talked about tonight comes from you know, some direct experience of having done this as either in research in an observatory somewhere. I mean, I worked in observatories that were so big that the entire floor moved up and down as an elevator to meet the telescope because it was so big. Oh, yeah, it's beautiful.
Have you ever worked with adaptive optics? I think I asked you that before. I'm not sure if I did or not.
Maybe so, but I've never had the opportunity to work with an AO system. But that is how, for instance, there is actually, I just read this, you know, there is an AO system for amateurs that's coming out. And so I can imagine that.
It's a big question. Is it going to be affordable? Because the cheapest one I found, because I was looking for it for Paul, obviously, and I was like, man, that'd be great to incorporate this in there and help him with some of that atmospheric distortion and stuff. And I'm like, okay, $23,000. I was like, well, it might be a while. I mean, it's expensive. Yeah, man. It's a three-phase, I think.
That's expensive, but it's totally cheap compared to what, you know, the first AO system cost.
Right.
You know. It's actually a really good buy, actually. And, you know, if I could do it today, I would. I've got a couple kids in college. But you know, I own my own company, and I have a visual effects company. We actually are doing large-scale solar systems, actually, for several hundred buildings around the country. It's a years-long job. And, you know, that could actually provide some money if I shunt it to the side.
Now, do you have a studio or a shop that you do all this with?
Yeah, I'm in my office now, which is made up to look like a World War II battleship, complete with rivets on the wall and rust and real portholes for windows. But then I have a hatch for a door. But next to me is my shop, and it's where I do all the real fancy stuff. You know,
is it possible to get a tour of this place with a video camera? Wink, wink.
Absolutely. No, of course we can do that at some point. Once you get video up and done, I'll be happy to. I'll be happy to take you folks on a visual tour.
Yeah, I was thinking about that for the channel. Maybe like a tour of Marc's studio.
Oh, it'd be fun. You know, and then I could do a tour of Doug's studio, and you know, up in Massachusetts where his studio is, because I work with Doug a lot, and you know, we're actually. Doug and I were just invited to speak at the, and Doug doesn't know this yet, but we were invited to speak at the 40th anniversary of Close Encounters of the Third Kind conference, which is taking place actually at Devil's Tower.
Oh, neat.
And I haven't even told Doug about that. I was actually supposed to, so you're finding out before him. Nice. All of you are.
Speaking of speaking engagements, we had talked earlier before we actually went on the air here, Pine Bush. Up in, I believe it's May.
Oh, yeah.
Up where Bill is and stuff. I have talked to Paul about it, and we had talked about, because there's two things that we could have possibly did this year. We could have went to Pine Bush, or we could have did the Carolinas for the eclipses. And I think after talking to Paul, we're more leaning towards to going to Pine Bush, and I'm pretty sure that's what we'll do. I still want to get a complete confirmation from him for that, but I just think it'd be a neat time with how many speakers that are going to be up there, and now Bill's working out some of the kinks to try to get us our own little area and stuff. And you're going to be there, so it's going to be one hell of a weekend.
I'll be doing a talk. I'll probably be talking about my astronomical specialty, which is exoplanets, but that's not dry and boring, because exoplanet study is the most thrilling place you want to be right now. Because, you know, you look at the moon. The moon is geologically inactive. It doesn't do anything fancy. It doesn't have any tectonic activity. It may or may not have little volcanic activity that may or may not be the result of, some kind of subterranean material movement. But bottom line is the moon is pretty much done. It's not going anywhere. But, you look at the moon and then you look at the Earth and you think, the contrast between these two bodies couldn't be more different. What's different about us? What's different about the moon? Why doesn't Venus have the similar atmosphere as the Earth? Why doesn't Mars have a similar atmosphere to the Earth? I mean, that's kind of goes back to the concept of a habitable zone, right? So, I'm probably going to talk about exoplanets and all that stuff when I get to Pine Bush. That'll probably be where I go. But
Awesome.
I can't wait to go. That'll be fine. Then I got to go to, like I said, I might have told you before, I got to go to Roswell in July. I'm booked into that conference. They want me to talk down there. So I've never been to Roswell. So it'd be
Do
kind
they
of cool.
usually stream those conferences and stuff online, or is it just pretty much for the people in attendance?
Yeah, it's pretty much for the people in attendance. And what they do is they have videos. They videotape everybody's talk, and then they turn around and they sell the videos on DVDs, to people who want them.
Oh, okay.
That's sort of a revenue stream for them.
Kind of the same way that the UFO or the UFO conferences. I'm trying to remember. There's an official name for them, but
There's
is that the same
UFO
one?
Congress.
Congress.
UFO
That's
Congress.
what it is, UFO
Yeah, the
Congress.
Congress in Fountain Hills, Arizona, where I speak I speak occasionally at that conference. The MUFON conference every year. That's the Mutual UFO Network conference. The last one was in Orlando, and I actually did a day of training there for everybody. I actually took our MUFON people and I trained them on photo and video analysis. And then there's conferences all over the place. The Mutual UFO conference, the Mutual UFO Network conference is actually, MUFON is its charter is the scientific search for extraterrestrial life for the benefit of humanity. Basically, that's our charter, and so we try to have people running this organization that are actually scientific minded, and we come under fire a lot, from people that try to say that we don't do it. We don't do enough. We not, how could you possibly think the moon isn't flat? Stuff like that. But you know what? We can tolerate that. So there's a lot of UFO conferences around the country that are actually worthy of going to. And the UFO Congress run by my very good friend Alejandro Rojas. He's phenomenal, and Alejandro with Open Minds. He really does a good job, and that organization really does a good job. And Mutual UFO Network does a great job under Jan Harzan. So it's a really neat set of conferences out there. And the Mutual UFO Network conference, we try to, like I said, we try to be more scientific. But it doesn't mean that you go there and all you do is hear this droll scientist at the microphone talking, and then this is what happens, when these rocks collide. We don't have that problem. Okay.
Monotone Ben Stein.
Yeah, there's no Ben Steins at these conferences for us. No, thank you.
Yeah. Awesome.
Yeah.
Well, Mark, man, you said it all.
I did. I said it all. So yes. I don't want to have to repeat myself now, but I'm loving the stream anyway. That was fun.
Yeah. Tonight has been absolutely great, and I don't want to keep you too long because I know you got stuff to do and sheep to count.
Oh, I thought you were going to say that you just, running out of things to say.
Oh, no. I mean, we can keep going if you want to. That's up to you. I just didn't want to run you over time. But if you ain't doing nothing, we'll keep you around.
Well, it's like I said. I mean, I just, I don't want to stop repeating myself or anything. But I mean, you certainly have, a good viewership right now. Yeah.
It's been a pretty good night.
Yep.
Actually, it's been pretty calm too.
Mm-hmm. Yeah, no one's actually gone off on me yet, so I'm pretty happy about that.
Yeah, not yet. Not
bad.
We're gonna be doing Jupiter coming up in about I'm guessing 3 or 4 weeks. It's slowly leaning back towards nighttime. Well, it's after midnight at this point, but it's slowly coming back, and hopefully we'll be able to start doing that during the new moons. Any tips for that for us? Because last year we actually
observing Jupiter.
Yeah, last year we actually did it where we had it in long enough where we actually saw it, the spot actually rotate around, because it only really takes about 90 minutes for that, for Jupiter to rotate. So we actually watched the storm actually rotate around the front and around the other side. It was really neat.
That's so cool. Yeah, I was using as far as tips go, the best instrument to view a planet with is a refractor anyway, not a reflector.
Mm-hmm.
And I had the benefit of using a 20-inch refractor at one of the observatories I was at. And I actually just decided one night to break from my parallax star star photography I had to do for the program, and just point the telescope at Jupiter. So I pointed the telescope at Jupiter, which was kind of near the horizon at the time, so I actually had to bring the floor way the heck up into the air to meet a telescope that was almost horizontal. And I'm looking at Jupiter with this gigantic lens. It's literally the size of your two hands together making a circle. Okay, the lens, the eyepiece itself was probably 5 inches in diameter.
Yeah.
And to look, she had to hold the lens up and place it against this flat glass back plate on the refractor, and look at it. It was sort of a kludge because the telescope was never meant to be used visually. It was meant to be used photography for photography. So you'd hold this lens up to the plate, and it's freezing cold. My hands are frozen, and I'm glued to this eyepiece because I'm counting the cloud bands on Jupiter, and I'm seeing 19 cloud bands with Jupiter near the horizon. I could only imagine how much better that would have looked if I could have waited around for it to be up overhead. But it was just stunning, and I'm really telling you that a lens system is better than a mirror system for looking at the planets. It really is. And it's not just experience telling me that. It's actually, the physics of how the light can focus and so forth, and the contrast of the image that you get. It's just amazing.
Right, and last year Paul had that had Jupiter in it. I mean, we just had it actually. I think it's one of the welcome videos that I put up on the page for new people, like not returning subscribers, but for new people just checking out the page. And I mean, he nailed it. Nailed it.
Wow.
Just Jupiter, like perfect. I mean, you could see all the bands. And a couple times last year, we were actually able to get ring separation with Saturn, which is awesome in itself.
Mm-hmm.
But yeah, I mean, Paul. I cannot wait myself to get Paul on with Bill because I got questions for him too. So, I just have ones I've been holding back on because I would definitely want to keep it for Bill's radio show. And anybody that doesn't know, Bill is the guy that actually helped us get the audio up for tonight. It's Bill New York Skywatcher. Definitely go check him out. I'm pretty sure one of the mods in the chat can link you to his channel.
Thanks, Bill.
But yeah,
Thanks, Bill.
definitely helped us out and pitched a bullpen session for us. And even though his Giants were really losing at the time, he jumped on and helped us out and helped us get the audio going. And not to mention, thanks once again to Paul, just spending the time down there and just amazing stuff. I think
that's incredible, absolutely incredible. You guys have quite a little phenomenon going. I'm really happy to see where it's going. You're doing a great job.
Yeah, I wish I knew there was this many people that were into the moon and stuff, a while ago. I would have, been looking.
It all happens. It all happens when it's right.
And there's one guy I wish that would totally come back onto YouTube, and missed a guy. I mean, he's just a down home, good old boy from Texas, and the guy's name was Bill Bryson.
Okay.
And what he would do is he made his own kind of little thing with his telescope. Something how he did it with a webcam. But he had really good views of the moon. And he did it for like a year, but he would go on there and he would basically just give educations on the moon, like what you were looking at. Really good guy. He would answer everybody's question. And then one day he just kind of disappeared, like with a snap of a finger.
Really?
And everybody thought something might have happened to him, but here we found out that his sister took sick, and up here in Pennsylvania, and he's been up, with her and dealing with all that stuff. But yeah, I actually got in contact with him, and hopefully he'll be starting to do stuff again soon. But and Bill is in chat, so finally.
All right.
What is up, Bill? Once again, thank you so much for the audio. Sorry I had to interrupt your Giants game once again, but thank you so much for helping us get the audio fixed. And once again, I will be talking to you tomorrow. To make sure we have everything hooked up for future, because once again we do have Dave Schott coming on, we do have Rick from Look Now TV coming on, we have we just have so many people lined up, and hopefully we have a couple surprises too, not to mention Paul coming on to Bill's chat, because we want to pick a night where Paul's not working the scope, and have to pay attention to that. We're going to do it on a night that Bill's streaming, doing a sky watch, and we'll actually have Paul on. That way you guys can ask questions of them. I can get out some questions as well. Cannot wait for that. And we have to actually pick a date for that. And Bill's saying hopefully this week, weather permitting. So yeah, the full moon, you're looking at the 12th, I think it is, or the somewhere around there. The 11th, 12th, maybe is a full moon.
Okay.
I don't know offhand. So once again, the full moon is the crappiest viewing
Yep.
for us.
No contrast.
No contrast. It's just a big white ball. Somehow Paul gets that edge working and does a fantastic job. Even with a super moon, he was doing great. But
Yeah,
yeah.
it might behoove me to actually mention that there is a website where anyone can go to look at the current craters that are on the terminator of the moon, that area between dark and light, so you can actually see exactly what you're seeing in those shadows.
Mm.
Now, I don't know if you ever mentioned this to anyone yet, but it's a website. Let me look it up here. Sure. Now that I've mentioned it, I can't find it. Right? Don't worry, I have it. It's the Lunar Libration site, and I'm trying to find it. I'll let you know in a sec. I'll find it. So go ahead. Just pay no attention to me. Go ahead, do your thing while I'm.
No, I was just chilling. Oh, I should actually say thanks to all the mods. Yeah, the mods have done a great job tonight as well, and a lot of them stuck around. So awesome, guys. Very good. Bill is looking forward to speaking with Paul, as am I, and definitely about the UFO Festival in May up at Pine Bush. We're definitely going to chit chat about that. And Mark, I definitely want to have you on again, possibly even when we do the Jupiter stream that we've been talking about for a while. Okay. And of course, more moon streams. Of course, if you ain't doing nothing, definitely need to stop by, even if for a couple minutes. Just come on, stop by. I'm sure you'll be over on Bill's channel for a while.
Sure.
And
I mean, I'm supposed to. I made a promise a long time ago to talk about the history of everything. We were going to talk about where the Earth came from, where the Moon came from, and then go through all of the processes that led to Earth to where it is, as we know them, as we best know them, and then talk about what this means for us in terms of other planets elsewhere. Because and I'll just mention. I mean, I'll mention briefly, but I think by now you know me. I say mention briefly, and you got to shut me up. But one of the things that happens is when you have a planet like the Earth, very dynamic, very active, a lot of extinction events, in the end, out comes us. All right? Just to go right to that point. Well, in UFO lore, you have reports of grays with the black almond-shaped eyes and so forth. You have reports of these reptilian creatures, which kind of reminds you of like Sleestak from that joke show, Land of the Lost, back when, we were kids or whatever. Well, but then you have to think logically. Had the Earth never had that extinction event at the Paleogene era right there, 65 million years ago, okay, what might have happened if there was an intelligent destination for, say, dinosaurs? Could that have happened? Well, we know there were some theropods, meat-eating dinosaurs back then that actually were approaching a larger cranial case, a bigger brain capacity, which we equate to increased intelligence, and they were snuffed out. So could that have eventually, over millions of years, led to what we were, but maybe with a reptilian look? I don't know. It's a journey. It's not a necessary destination. That is to say, intelligence. So it's possible. So when people report these creatures, what would an ultraviolet star might cause a species to, over time, develop a skin that could actually reflect UV very well. Maybe that's what the gray is. Maybe the gray is that. Maybe the black eyes are protection against ultraviolet, or increased light capacity for light gathering power for being farther out from a dimmer star, perhaps. Don't know. So we look at the morphology of these planets that we see around other stars. We know where some are in their habitable zones. We also know that most of these planets are found around red stars, very low temperature, low luminosity, that is low intrinsic brightness stars, 100 times dimmer than the sun. And for a planet to be in the habitable zone around a star like that, it has to be very close to the star, so close, in fact, that it will endure tidal locking just like our moon does to the Earth, with the same face facing it. So could there be life? on a planet like that? Well, if it's in the habitable zone, which means there's liquid water on the surface potentially, then that could be. And that means that we now have a whole new place to go with science fiction, man. We can actually dream up a reptilian creature that might actually be plausible for the first time, because we can consider that maybe dinosaurs and that particular location in the evolutionary history on this planet is kind of a norm for the universe. Maybe there's other dinosaur planets out there that might look different. Maybe they last a little longer. Maybe they never really get to exist at all. Maybe they don't get past the Cretaceous. They don't get past the Triassic. We don't know, but they might exist out there. And if that's the case, now we have to consider that it's more important than ever to study our own planet and to learn about our evolution and how we came to be. Because the more we're learning about that, the more we're learning about that, the more we see that we are just a potentially small, isolated case in a galaxy full of other living creatures that are out there.
Definitely. And Bill, I gotta say, Bill, if you want to join the Skype chat now, if you're all done,
I am here. I was enjoying the conversation that both of you were having. I was in my bed laying down because I'm not feeling too great, but you guys did a tremendous job. It was so interesting, the topics you discussed, and definitely I think this is something that you guys can do again sometime in the near future, because Mark has so much to discuss, and Keith, you do a great job here with Paul. I think this is by far the best lunar stream, and what you guys are going to be doing in 2017 is going to be simply amazing. So great things to come, or not that saying that already things have been great here, but
yeah, it's been a lot of fun.
Oh yeah.
And once again, thank you to Paul that isn't joining, that actually should be on here right now, but somebody's got to work the scope, right?
Well,
but once again, Paul will be on with Bill and myself and whoever else Bill clamors up on Bill's channel when he does a Skywatch, so we can get to know Paul a little bit better.
Now, I got a question.
Definitely.
I got a question. Is Paul going to be available sometime this week if the weather cooperates?
He's in the chat, so he should be able to answer you. He's
he is
slowly. Yeah, he's been typing a little bit every night or all night long, so he'll probably answer you.
Oh, great!
Sometime in there. Yep.
Oh, that's cool.
I think he said earlier that he was in.
Okay.
So yeah.
Well, what's his name in the chat?
Yeah.
It would be P. Gurnis in the chat.
Oh, cool.
Okay. I didn't see that. Maybe it is in there. I don't know.
Yeah, he's a moderator. You'll see him. It'll be in blue. It's a little easy to catch then.
And Mark, by the way, Amanda is looking forward very much so.
Holy moly! I think you got a little celebrity crush there, Mark.
When he does
that, Amanda is ready. She's been wanting to hear this. Anytime you mention the name Mark D'Antonio, she is on it.
Well, she hasn't been feeling
ready to hear stuff.
She's been under the weather. She's been battling a bad cold. So I was hoping that once she feels better and she's up to speed, to get her on with us, of course. And when Mark is ready, maybe in a week or so, and he wants to come on and discuss the history and get into it in detail, then when Amanda's up and running, then maybe we'll do it in the near future, Mark.
Right. And you're going to go from the beginning of everything, right? The beginning and just work your way up. So we're going to need about 6 or 7 hours.
No, the point is that you don't get to hear the full complete histories. You get to hear a little bit about the moon and then this crater on the moon. You get to hear about this really cool feature on the Earth, like it was before, the Manicougan Reservoir crater impact area, or the Barringer meteorite crater. I got a funny story to tell you about that in a second. But you don't get to actually hear about the whole generalized history, start to finish, to where we are today from the beginning. You don't get to hear how that all went together. And you know what? I think many people are interested in knowing what happened way at the beginning and how it led to us. I do a really interesting illustration of that at some conferences. I actually do this with a roll of toilet paper. I draw on a roll of toilet paper on all the squares, 321 squares, 4 inches across.
Man,
I draw
boredom.
The whole, right, huh? I don't have a life, man. I draw the entire history of the Earth on this, from the very first bacteria all the way to where we are in the conference room, or where we are in this conference right there. And it's about 117 feet long or so, and it's got everything on it. And what you notice is that this thing winds around. I literally go out into the audience with it, and the video guys hate me because I don't ever stay. I hate staying behind a podium. And I go out and I interact with the audience directly. I get people to help me, and we make this long toilet papering of the audience, is what I call it. And I've gone around some audiences almost, almost like 1.5 times, okay, for the smaller conferences, and like halfway for the larger. And what you end up getting is you see that, about 3 feet in, you see the moon forms from the very first sheet that was unrolled. And then after that, a whole lot of nothing until you see the first bacteria, around 3.4 billion years ago. And then a whole lot of nothing, and on and on and on, blank after blank after blank, until we finally reach the first, the Cambrian, the pre-Cambrian era, where we start to see the first little tiny bits of life. And you notice how much of an explosion of life there was. And then you see how that life just exponentially grows and diversifies as you get closer to the present day sheet of toilet paper you're on. And only in that last sheet, on a line that's thinner than a pencil line drawn with the sharpest point, that represents everything that we've ever known, and represents all of humanity since, from 50,000 years, from ancient Sumeria, actually, all the way to today. A line thinner than a pencil line on that whole thing. And that is where we are. That's how we've evolved. But one thing you notice in particular is that, 3 feet from the end, that's where dinosaurs died. 3 feet from the end. So you look at this roll of toilet paper and you realize, holy crap. Okay, never mind. But holy crap. Okay, dinosaurs are recent history. They're not ancient history at all. And you see that that's the case when you look at this. You realize, my gosh, this points it right out. This all happened near the end. And if anyone was looking at this from a cosmic perspective, they'd say, dinosaurs, humans, they're kind of all the same to them, because it looks like it's all happening at the same time for them.
In the timeline of things, it's pretty close.
Yeah. But anyway, so that's cool. And so that's part of talking about the everything. But the funny story I wanted to tell you was about the Barringer meteorite crater. That meteor was an iron meteorite that hit, 19,000 years ago or so, 10,000, I can't remember. But in any case, when I was getting my degree in astronomy, the head of the department, the chair, in fact, of the astronomy department, was a really nice guy named Arthur, and I don't want to give you his last name, because if he's still around, he's going to come after me. And what we did was, as a joke, they had a piece of the Barringer meteorite there. 2 feet by 2 feet by 2 feet. And we, it took 5 of us to do it. We lifted it up, solid iron, and we put it on his chair in his office. And we left it there. And then we went away. We left. And he came back, and we were doing our work in one of the libraries, and we could hear him bellowing and in anger. He just did not get the joke, and he came out and said, "Who the hell put that meteor on my chair?" And then we all basically went in and took, credit and or blame for it, and then we had to move it back. But we had a piece of that Barringer meteorite, and just that little tiny piece was massive and really, really heavy. So, imagine that, when that hit the Earth, it hit it at such a speed that it produced this gigantic crater. And, craters can be, 10 times the size of the impactor, So I think that's really cool,
Mark, what about the latest information that there was a large impact in Antarctica? It seems like they detected something from space.
They might have detected an underground anomaly in Antarctica, and I actually did that for one of the. I think I did that for What on Earth, the latest show, the latest season. What on Earth, I talked about that because that was one of the stories, and they wanted me to research it. It looks like it's a possibility that what they found under Antarctica could be related to the major extinction event from the Permian era, and that means that this is the largest extinction event on the Earth. We might have found the smoking gun for that impact, and that's, I think, what they're talking about with that. It's a large ring of shocked material underneath the Antarctic mainland there, and it's very possible that that could be the remains of the Permian impactor.
Interesting.
Really cool stuff, yeah. I mean that destroyed 98% of the life on Earth.
Wow.
You know. So I mean, we had, like I said, 5 major events. So, you know, imagine a planet that didn't have any events. What would its life look like? What would its evolution look like? You know,
Right.
unobstructed by rocks from space. I mean, it could be all different. So we don't know. We could suggest that we could suggest what a life form might look like on another planet, but we only can do it from the perspective of being this life form on this planet. We don't know what another life form might look like.
Well, wouldn't gravitational forces and obviously atmospheric conditions and what the atmosphere may be consistent of, wouldn't that obviously be a vital, significant importance about how the life would develop on another planet anyway? It doesn't necessarily have to be how we are, because of, you know, we have the certain, what I just mentioned on our planet, but it may not be the same on another planet that has life. So wouldn't life
That's right.
evolve differently?
Yeah, of course. I mean, you know, like a planet. Let's say there was a planet out there the size of Mars, okay, and it had life on it, an atmosphere, and so forth, in the habitable zone, had liquid water, say, okay, and life could develop. If that's the case, then because the gravity on that planet is less than the Earth's, I think like it's what 0.3 of the Earth's, then creatures on that planet would tend to grow larger. They might be larger in general because they're not limited by the gravity. Consequently, on the other side, if you had somebody that was evolving on a planet the size of, say, Jupiter, where the surface gravity was just, you know, incredibly high, to overcome that surface gravity, they would be developed with just these really large muscles and probably extra benefits from not being crushed by the massive atmosphere. Such a being on this planet would be, you know, it'd be incontestable as a adversary. You would just not be able to probably take it down. It probably have developed and evolved way past just by its evolution, its ability to survive and its ability to you know, say take over an Earth if it wanted to would be literally he'd be unstoppable, you know, because he'd be so big and so powerful. So, you know, again, and if their atmosphere is not the same as the Earth's, well, then they'd have to have some kind of breathing apparatus to survive here with their own atmosphere. And if their own atmosphere was something poisonous to us, well, then, you know, we might be lucky. We might be able to escape being colonized by aliens such as those. So,
Mark,
Amen.
Go ahead, Keith.
No, I'm good. I'm just sitting here playing with what the moon looks like.
I see a lot of Spanish-speaking people. We're going to need a translator eventually, huh?
Yeah. What happened was there was the video from December 3rd that had the pass by in it. Got picked up by a channel from, I think it was Brazil. Don't quote me on that, but I think it's somewhere. And he had 10 million subscribers, and he'd linked directly to the channel. So we got a lot of subscribers and people from that. So yeah, we've been looking for Spanish-speaking people to help them out, because we don't want to ignore them altogether. You know, obviously there's going to be some good input coming from them as well. So we want to make sure that we hear it and see it.
Yeah, I get many of the best questions I get are from people around the world that, you know, I have to put their questions or emails through a translator first.
Right.
Or they try to speak English and I don't quite get the meaning, and we go back and forth 3 times before I get it. But I mean, just because they speak a different language doesn't mean they're you know, incapable of asking a very cogent question. It's
Exactly.
awesome. There's a lot of very intelligent people out there.
Now, Mark, you do have an upcoming book that you're going to be releasing soon, right?
Yeah, it's called The Populated Universe, and it's a book on, well, it's a book on the history of everything, kind of what I'm going to talk about. But it's also primarily a book on exoplanets and how the search for exoplanets really impacts us here on Earth, and what we're going to have to do to be able to reach these exoplanets someday. It's really it's an examination of my feeling that life is the rule, not the exception in the universe, because everywhere we look, we see that the universe is making the building blocks of life. You know, on Europa, Enceladus's geysers, Titan's surface. Okay, right here in our solar system, we see the building blocks of life. Comets. Okay, Churyumov-Gerasimenko, Comet 67P, right? The one that the Rosetta mission landed on.
Mhm.
That comet is surprising us with discoveries all the time, but it has hydrocarbons, complex hydrocarbons on its surface, tholins, all building blocks of life being brought here, amino acids being brought here when these comets impact the Earth or when they fly here. And we were hit by billions of comets, billions with a B. And it's hard to conceive that, but it's true. We, in the era of bombardment, the same era when the moon got all those craters, okay, I mean, the moon's craters have craters. I mean, that's how many times it was hit, right? So when we look at the era of bombardment, okay, we had a lot of comets hitting the Earth. They brought, besides water, they brought amino acids, they brought hydrocarbons, they brought a lot of building blocks. Second, meteors hit the Earth and asteroids. Those meteors, like the Murchison meteorite from Argentina, that one brought amino acids to the Earth as well. So amino acids, the building blocks, were brought by comets and meteors. On top of that, the Earth itself, through the Miller-Urey experiment back in the 50s, 53, they actually discovered that just by taking a primordial Earth's atmosphere and keeping it in a flask and then hitting it with bolts of electricity every now and then, you actually would make all kinds of amino acids. So the Earth makes the building blocks of life. Comets deliver the building blocks of life. Meteors deliver the building blocks of life. The solar system is creating them all over the place. It's telling me, and this is why I wrote the book, it's telling me that the building blocks of life are very common in the universe. In fact, they're actually, it's less common to see something not making building blocks of life than something making building blocks of life. So, if they're that common, they're that prevalent, I felt it's important to discuss them. It's important to explore the exoplanets, because that's obviously, besides my specialty, it's also where we are going to have to go someday. So, Nino.
Is it possible that a panspermia event could happen now? In other words, is it possible that something could come in to our planet and create a totally new life form?
You know what, Bill? We don't even know if that hasn't happened. Okay. Panspermia undoubtedly has something to do with this, because comets played a bigger role than people have ever given it credit for. More comets have hit this Earth than previously thought through the research and studies. And so undoubtedly panspermia is something, panspermia being the origination of life coming from off the world as opposed to the world. Certainly panspermia has played a role in the development of life on Earth. Don't know how much it has, but it's played more of a role than people realized. And so it's very likely. And I believe it's true.
Now, I know you and Keith touched on this. I heard you guys earlier. Wouldn't it be more feasible maybe to create a colony on the moon, just as pretty much as a jumping point, as a step in the progression of eventually going to Mars, at least due to the distance where, we can actually do an experiment off-world on Mars, where it's more feasible for the travel distance and just being able to do some valid testing by having a colony on the moon before we go off to Mars and do it at such a vast distance.
You got me smiling here because, I've often said kind of a similar thing. I don't necessarily believe that going to Mars first makes a whole lot of sense, because we're going to need a lot of resources for a permanent presence on Mars that are going to come from the moon. They're not going to be shipped off the Earth's ground up into space and then off to Mars. I think they're going to be mined off of the moon, and I think that the mining will have plenty of mining colonies at some point, getting the resources off the moon, and we're going to have large ships built on the moon that are going to be able to leave the moon at a much lower escape velocity than from the Earth, and be cheaper to fly off the moon, built on the moon, crewed by people that are on the moon as inhabitants and or workers, and they'll get out to Mars from there. The only problem is we're going to have to be really fancy about the way we get to Mars, because Mars is at closest approach to the Earth only a few times, at certain times. Other times it's farther away. If the Earth's on the other side of its orbit, that's a significantly different distance. It's longer. So we want to be there. We want to go when the Earth and Mars are going to be closest together when the ship arrives at Mars. We want to make sure that we leave at a point where it gives the ship enough time to travel, and by the time it gets there, it's going on the shortest route. Mm-hmm. So there's a lot of logistical issues with trying to get to Mars, but I do believe that the reason we want to go to Mars, instead of the Moon first, I think that the thinking is, Mars has an atmosphere. Mars has a way to possibly be colonized easier than the Moon. And Mars also stands a chance that it could actually hold life. The Moon, we know, doesn't have anything living on it. Right. The Moon is a rock, and it seems to be dead. It's airless. So going to Mars, we actually have a little bit of an advantage, because even though it's farther away, Mars will also stand to teach us an awful lot about our own planet, because we will be able to dig into the soil and look for living microbes that might still be there. I've told you about this before, Bill. Back in, I think it was 2012, there was a bloom of methane that was seen on Mars during the Martian summer. Now, a bloom is a plume, basically, that seemed to expand. It was a big plume, not small. And it was unexplainable and remains unexplainable to this day. And it wasn't an artifact, it was real. So how does that happen? Well, methane happens for a couple of reasons. One, volcanoes spew a lot of methane. Mm-hmm. So you have to figure, well, okay, maybe it was a volcanic eruption on Mars. But Mars has been tectonically inactive for several billion years. In other words, no volcanic eruptions. All the volcanoes on Mars seem to have been extinct for many billions of years. So that means, okay, well, maybe the methane was trapped in the ground from a volcanic eruption billions of years ago. Well, that can't be true either, because methane doesn't last that long. And so the methane will deteriorate in just a few years. And I mean like 8. Mm-hmm. It doesn't stick around for a long time. So the only other solution is that it's the byproduct of organic creatures, meaning microbes, bacteria poop or something, I mean, that's kind of what it could be. So that methane bloom could have been the result of microbial action. And they looked for it the next summer, and it wasn't there. So it's really perplexing why we'd see it at one point and not at another. Another alternative possibility is that this is dormant life. It's life that it does exist on Mars. Actually is dormant, and it just comes back once in a while under the right conditions. I think that's pretty cool. I think it's pretty cool.
Yeah, that is, actually. Now, I have one more question. I know Keith is probably getting ready probably in a little while to wrap up, but what about...
Yeah, Paul said about 11 o'clock, so
okay.
It should be...
Well,
go ahead,
Keith's
Marc.
shaking his head going, why didn't Bill just come in here and take over the whole thing?
No.
Oh, I'm kicking back and listening now.
That's what I was doing earlier.
Right.
But what about...
Keith was running out of things to say,
What about this... there's a lot of speculation that private industry, you have these private corporations that are eventually going to go to Mars. We've heard about the 100 people that were screened to be volunteers to go on that one-way mission. And wouldn't it be more, I would say, economically to the advantage of a bunch of nations like we did on the ISS to get together to do a joint mission to Mars? Because the budget just to do something on this scale is going to be incredible. And
well, honestly, we are going to end up having to do that, and we do that anyway. Mm-hmm. The ESA and NASA have relationships, and the issue really is that a mission of that magnitude must involve other world countries, and the reason is because not only of budget but of science and research. There's an awful lot that has to be done before we ever leave the ground. All right, and once we leave the ground, then it has to be all hands on deck for the entire duration. Deemed important duration of the mission. So that could be however long it takes to get there. That could be getting there and then setting up shop. I said before to Keith that the TV show Mars is actually really well done because it highlights many of the issues that we have to face, and it does indicate that an international team is actually going to go to the Red Planet and not just Americans going to kick butt and take names, that kind of thing. So I think that's pretty cool, and in fact, I think that's the most exciting part, is that actually shows, in my view, kind of like how it's going to go. I think that's pretty clear that we have to depend on international cooperation to get there at all.
You know what, too, though, Mark? If you look at it just going outward into the universe, I think humanity has to be represented as a whole. And not just, it's not just one country or nation that's going at it. I think it'd be great if everybody could come together on some type of same page, so to speak, where they can engage and represent humanity, an international team. If we're going to move anywhere forward in the future, because what's going to happen, we're just going to start going and claiming this is mine, this is ours, it's just going to start all over the process.
Well, think about this. We've already been through this, We've already been through this exact problem, haven't we? Where have we had that problem? Here on Earth, and we resolved it. Where on Earth have we had that problem? You like my questions? I always ask you questions.
I know you're making me think right now.
Yeah, we've had this problem on Earth. If anyone in the chat knows where it is, where have we had this problem where we had to deal with an international consortium in order to decisions for what we were going to do? And I'm not going to go further than that, but if anyone knows, post the answer.
My hand's raised.
Your hand's raised? Okay.
I think I have an idea, but I'm not exactly positive.
Well, put it in Skype.
All right.
I have to find the Skype window first. It's somewhere buried in here.
Because, I mean, I was thinking of a couple of things, but I don't want to give it away either, if he said it about chat. But I was thinking just basically based on a UN thing, and I'll type it in chat. I don't know exactly where Mark was going on it, so he comes up with these.
I couldn't give away too much.
On the count of three, Bill, we'll say it at the same time, so we have the same one.
Well, I was thinking of that. I put it in Skype.
Oh, you did?
I wish I could find it.
Because every, the United Nations came together to decide what was going to happen after World War II.
I see. No, Bill, that's actually not correct.
No.
That's not correct.
Okay. What was yours?
It's still
Keith?
your turn. It is still your turn, Keith.
My guess would be Antarctica.
And you are right.
Oh, okay.
See, because Antarctica was a no man's land. No one owned it.
Right.
And we had to go down there and figure out what we're going to do. Now, we have McMurdo Station. Okay, we have an American presence. We have a Russian presence there. We have a presence of other countries all over Antarctica. But they all work together. They don't act totally separately. The Russians actually will work separately, okay, and that is probably because of the military work that they do. But they don't. They all pretty much, they will often cooperate with each other. And Antarctica is the one place where we face the same hurdles that we might face going to Mars with an international consortium, And the nice thing is that going to Mars, every single person there will depend for their life on everybody else. So, because no one person is going to be expendable, but no one person is going to be someone that's going to be necessary for everyone else to survive. There is overlap and there'll be backup and so forth. So putting a bunch of people together is going to be a very tricky selection. And so you have to do that in a way that if one person dies, it's not mission over. You know what I mean?
Right.
If the mission commander falls off a Martian cliff, everybody else can't be at risk for that. They have to have a plan, an alternative plan to be able to do whatever they have to do to fill in the gaps and fill in the holes. But in such an unforbidding place, or a forbidding place like Antarctica, where the temperature can go negative in no time and stay that way for months at a time, we have to be on our toes, right? We have to know how to handle that. Well, at Mars, it's even harsher. During the daytime, ultraviolet radiation can hit the ground, and if you're outside exposed in some way, not only will you get incredible burns and blisters from the ultraviolet radiation, you're also going to be hurt by the tremendously low pressure on Mars. So there's a lot of concerns that we have in a Martian mission, but it's similar to an Antarctic mission. And so you have to consider that. The biggest thing about a Martian colony is what? Self-sufficiency.
Right.
It has to be self-sufficient.
Mm-hmm.
When it's self-sufficient, then you can truly call it a colony and not a mission anymore. And that's the kind of thing that we have to go toward. And so we're probably, no lie, about 100 years from that, where we're going to see Martian colonies. I think concurrently we're going to see lunar colonies as well, because we're going to need raw materials with which to build spacecraft, with which to construct machinery that might be necessary on a Martian colony. And then we have to figure out how to launch it off of the moon in a way that can get it to Mars. And we'll probably use a circuitous route using gravity whips and other things like that, flying it around big, kind of, gain speed. So if its first step to Mars is, if a spacecraft is going to Mars, its first step might be to, head toward the Earth and do a tight orbit around the Earth to gain speed, and then whip off to the moon again, do a tight orbit around the moon to gain speed.
Right.
So a double gravity whip, and off it goes to Mars. So it might do that. So there's a lot of interesting technology that's going to have to come into play, and a lot of weird calculations that are going to have to be done. I'm pretty cool with all of that. I'm pretty cool with all of it. I think we can do it.
You know what, Mark? Also, I think we're going to see a lot of activity in the next few decades as far as the mining, the resources on the moon too.
Exactly. I mean, there's a lot of elements on the moon that, compounds on the moon that we can utilize now, that we do not have to, handle with the Earth. We don't have to use resources on the Earth. We can use these resources from the moon. Now, the moon is untouched. It is not. It's virgin territory.
Mm-hmm.
It's not. It doesn't really belong to anyone. It belongs to humanity. So anyone can have a presence on the moon. There's no law against it. The Chinese have a presence. That's they have rovers. Russians have a presence. Americans have presence. But they're not. Japanese even have a presence. But where we have to say the moon only belongs to one country, or only to us, or only to our small group of countries, anyone can go there.
Mm-hmm.
And it's the same way. There's no claiming territory. If you claim territory, you claim it for the planet as a whole. You claim it for the Earth.
Right.
Claim it for everybody on Earth.
And
right?
Just one more question. I know they're getting ready to call it a night, but I have when they did that projectile a few years ago that went into the moon's surface, what was the purpose for that?
Oh, they were looking for water in the dark side of that crater, the dark part of that crater. And the point is, and that was a precursor to setting up any kind of a lunar presence. One of the problems is we need water, right, to survive. Mm-hmm. So if we can get the water from the moon itself, well, that's great. So in the permanently shadowed craters that exist on the moon, there are some craters that never see light, okay, because they are at such an angle and such a depth or whatever that no light ever gets there. So if some of these craters in permanent shadow have any frozen material that's left over in there from the moon's formation, then we would be able to use it and mine it and use it for a settlement that's on the moon. That's why we're looking there. So that basically, it was just a spent rocket booster, basically. They crashed it into the moon, and they looked at the spectrum to see if there was any water. And I'm trying to remember the name of the mission. Do you remember the name of that mission?
No, I don't. I don't recall it. I know it was a few years ago, but were they able to detect any type of water that was released from the surface, or from deep within the surface itself?
I'm trying to remember. I'm trying to remember if that was the case. The mission was called L-Cross, L-C-R-O-S-S. That I remember, and now I remember. And I'm trying to see if they actually did find the water, but I'd have to look it up actually to see here. I mean, it hit with like the energy equivalent of detonating like a couple tons of dynamite. You know, I mean, it was really quite an impact.
Yeah, I remember that. I remember that. That was quite a bit. I mean, it's been a few years now, but I mean, and you know, we have all these other countries that have definite interest. Like China's projected 2020, they're going to have, I think, a manned mission to the moon or something to that effect. So there's going to be a lot of activity, which these guys, I'm sure, will be covering extensively. And you
we
guys
got our eyes on you.
You guys do a tremendous job here. You and Paul, I mean, it's just incredible what you provide for the viewers and for the people out there. And if people are watching, spread the word through social media. I mean, this is definitely one of the best streams you're going to see as far as lunar coverage. And yeah, definitely, without a doubt. That's my opinion. And I'm sure.
And by the way, on that L-Cross mission, going back to that, when that thing hit, okay, it made a huge, ejecta plume of stuff that came off the lunar surface, and they actually looked at that, and they could see the spectrum of water in that. They actually saw that there was water in that material.
Wow.
And that's a good confirmation. So that was what they actually saw was the hydroxyl radical, which indicates what happens to water after it gets hit by ultraviolet radiation. But suffice it to say, there was a reasonable amount of water that was found in that frozen soil. So like about a single %. But that's more than enough for doing a lunar settlement,
It exists.
Yeah. And there's many more sites where they expect there's more water concentration on the moon. So again, even on the moon, dank, dark, dry, okay, but it's got the building blocks of life sitting on it in various spots. I said it's the norm, not the exception. Yep. Pretty cool stuff, man. Yeah.
Beautiful moon
Keith,
tonight.
Did you have a good time tonight, Keith, or what?
I did. I had a fantastic time tonight. How about yourself?
I had a good time. This looks fun. I'm enjoying the streams, and I love it.
Yeah, I think we definitely have to do this again.
Yeah, we can pick a topic and just go crazy,
Yep, and we'll have the audio working this time. Which I must say thank you to Bill for getting us working and actually hosting the audio so we can steal it.
Yeah.
No problem.
That's right.
Or you just gotta get a mixer.
Should we tell Bill now that we accidentally activated his webcam and we've been watching him the whole time?
Oh my!
We'll save that for the next time.
Oh, okay, yeah, because I know that many of the people that watched it were getting their comments deleted up there because it was I don't know.
I can only imagine what's going to happen here in May, boy. Woo.
Right. The reason why the chat is so heavily moderated is because we have, and I've said this before, we have a lot of families and a lot of schools watching.
Yes.
That we don't want certain things going out over the chat, and we try to moderate it as best we can. Obviously we're not going to catch everything, but the moderators do a really good job.
They do.
Trying to keep it clean, and we got to the point where we were timing people out, and that would just make them mad, and then come back and just totally blurt out whatever. So we just decided to just go for the ban right off the bat, and it's only a ban for the actual stream that they're watching. They can come back then later, and hopefully take a hint. But because I've gotten so many messages just from families saying that they sit down and watch it together, on their TV, in their living room and stuff, and
it's educational, man. It's educational.
Yeah, and that's why this is so important. Where I really wanted to have you on because I wanted fact-based stuff on, not conspiracy theory. I wanted what is known, not So, but on that note, I know Paul has to work tomorrow. And I definitely want to let him get some sleep because it's 11 o'clock now. So I want to thank Marc D'Antonio for coming by and hanging out, and hopefully he will do it again. I presume. Let's hope we didn't scare him too much.
No, I don't frighten off easily. I get harder questions from the flat earthers directly. Believe me.
There you go. There you go. And what any TV shows coming up that you're going to be on for people to check out?
I'm on all the seasons of NASA's Unexplained Files, and I don't think I did the first season, but What on Earth? Um, and I'm starting up another thing too here in Connecticut with the local Mutual UFO Network group, and I'm working on their show, and we're going to be doing some TV shows. I did 2 episodes the other night, and I don't know when they're going to be publicized, but we're going to actually. I'm pushing them to put them up on YouTube. So I got those going on. I'll be attending and I think speaking at the conference at Pine Bush.
Yep.
Correct, Bill?
Yep.
Mm-hmm.
And then I'm in Roswell in May, and a whole lot will happen between then and now, I'm sure.
Oh yeah.
Awesome.
But I'll be happy to keep you posted.
Awesome. Definitely let us do so we can advertise it, of course, here on the Moon live streams, even when you're not on with us.
Mm-hmm.
So we try to, once again, as Bill calls it, the community. We just keep bouncing stuff off of one another.
Yep.
As you can tell, since we're running audio through Bill's channel. We'll get it done.
Right.
But yes, Mark, thank you so much for joining us. I really do
Thanks,
appreciate
guys.
it, and I definitely hope to have you back. Bill, lifesaver once again.
Have a great night to both of you. And are you going to be streaming tomorrow night?
Thank you.
Once again, the moon's up, so if the weather's good, most likely we'll be on.
Oh, cool. So stay tuned for everybody. Tune in tomorrow for another great viewing of the lunar surface and these close-ups. Tremendous job to all of you for what you do. And I really admire, and you know what? It's just inspirational for all of us that are involved in this to do the observations, and hopefully more people will become interested and maybe decide to pick this up and do a little bit of this for themselves.
Yep, and that's the goal.
Yep.
That's what we want people to do. We want more people interested in astronomy, more eyes at the skies.
Exactly.
Exactly. Indeed. And I'll keep you posted too about our UFOTOG 2 system, because we're going to try and accelerate that as best as we can to make sure that we get more and more and more activity captured by that thing.
Keith, road trip.
Awesome.
Road trip, Keith.
Yeah, I know, right? we got to get a road trip going to Pine Bush first, and then after that we'll talk.
Yeah, we'll think about the next step. Anyway, gentlemen, it was a pleasure to get this few minutes to speak with both of you, and looking forward to tomorrow night, Keith.
Yeah, it should be fun. Do you have any plans on doing any sky watches, Bill?
Not in the next few days. The weather is not going to be too great over here. We're going to have snow and rain the next few nights.
Yeah, I was seeing snow and rain for a week.
Yeah, that's what it looks like, honestly.
Holy moly.
Mark, have a great night and a great weekend.
That's why Mother Nature heard that I'm building an observatory.
All right, guys. I am back. It is just me. I want to thank you all for tuning in tonight. We finally got the audio fixed because of Bill. Really saved us there for a little while. Marc is such a great guy. Really knowledgeable. One of the smartest people I've ever met. Once again, and big thank you to Paul for constantly bringing this stream to us on every night that he can. And once again, the donation tab is up for fan funding. By no means do you have to donate or anything like that. That's just if anybody wants to. That goes in, and all that funding and everything goes directly to Paul to keep up with cameras and upgrading stuff. That is just for his expenses and whatnot. And once again, it's not a requirement. It's just there in case anybody wants to. But great views tonight, Paul. If you're still listening. We're going to wrap up the stream now, as you'll see the little, what do you call it? The text on the screen saying that we're going to wrap it up. I'm going to let this guy get to bed. Once again, thanks to Marc. Once again, big thanks to Bill for that. And thanks to Paul and everybody in chat, all the moderators. Great job tonight. Everybody that submitted questions, everybody that's still around hanging out. The video of this should be up in the next couple hours or so if you want to rewatch it. And once again, be on the lookout for myself and Paul on Bill's channel. If Bill's still around, or if anybody, and then one of the mods in the chat want to link his channel, feel free to do so. Me and Paul will be hanging out over there one of the nights when we can. So we're going to wrap it up. We will see you guys hopefully tomorrow night if it's clear. And we'll see you tomorrow. Thanks, guys.